थांबा 1 मिनिट. 1 मिनिट बघतो. आले. हॅलो.
सर पॅन्ट घालून घेऊ का? हा
हो.
असावी आपली तयारी दा
फिरताना दिसेल गेले.
हा फिरताना दिसतं हे काय चालू कर
काय
क्लिअर ना वायफाय वर लावलेस का आता
नाही,
सुरुवातीला लाव
तुमच्या वायफायवर लावलंय.
हा बरं मला शिकवलं आहे ना काल लावलं होतं मीटिंग आयडी आपल्याला ऍडमिन करतो ऍडमिन राहू दे ना नाव
त्यांना काय पासवर्ड टाकायला
जॉईन ते म्हणते का बरोबर 11 वाजता येतो
हो.
इंडियन टाइम
त्यांच्याकडे आता हॅलो हॅलो त्याचा आवाज येतोय
Hi, good morning. पाटील
आवाज
साहेब.
येतो? गुड मॉर्निंग सर, आवाज येते ना?
हो, आवाज येतो. गुड मॉर्निंग.
ओके ओके.
ओके.
5 मिनिटं सर वाट बघू. 70 झालेले आहेत स्टुडंट. आपले टोटल पार्टिसिपेंट 200 आहेत. सो
चालेल ना.
in 5 minutes we are going to start.
नो प्रॉब्लेम. We'll wait.
Hello sir, perfect दिसते सर. स्क्रीन शेअर.
दिसताना.
या दिसते.
मी जर अशी स्क्रीन टॉगल केली तर दिसते ना?
हा दिसते ना.
ओके.
हा हो दे. Hello, sir. Sachin, sir.
Hello.
Can you, sir, please stop your screen share for a moment so
Hmm.
that we are proceed with introduction. Sir. Introduction. Okay, sir. Shall we start, sir?
Yeah, we can.
Yeah. So good morning, students, and today's session guest, Mr. Sachin Gaikwad, sir. So it gives me a great pleasure to welcome you all and the today's session guest, Mr. Sachin Gaikwad, sir. One more time, I am warmly welcome all of you. So first, I'm giving you the short introduction about Sir. Sir did his MSc from Yashwantrao Chavan Institute of Science, Karad, with microbiology, and he has the specialities with uh, food hygienist and food hygiene food preparation methods or management. He also successfully worked for the managing different types of their standards like ISO 9001, ISO 22000. He also successfully completed the certification related with the ISO system, HACCP levels, and NEBO SH system. And he had the 10 plus experience in the food sector and currently working at the Real General Trading Covil DMAC at the Kuwait. Also, he worked for the some companies like Gadre Marine Food Export, as well as sub companies from the Abu Dhabi, Dubai. So more details you will get with their session also. So I am requested, sir, to
से बात
start
कर
their
रहा है
sessions, please.
ये
सर म्यूट फक्त अनम्यूट करा सर स्वतःला.
Hi. Good morning, student. Uh, Thank you, Suresh, for the nice introduction. So we'll start the session directly regarding our quality assurance and quality control in food industries. Okay. Before starting, there is some already you are all are the Zoom users. There are some ground rules that please keep your audio on mute and video also it should not be displayed because it may affect the bandwidth. Another thing, if you have any connection issues, communicate to your course coordinator, Mr. Suresh sir. And if there is a for many peoples or many students you got the same issue, just communicate me that then I will re-log in again. Fine, we'll start the session. So in food industry, are you able to see the screen, sir?
Yes, sir. Yes, sir. Yes, sir.
Okay.
Clear, sir. Yes.
Okay. So my introduction is already there. I worked as a microbiologist, QA in charge, senior consultant in India, while as an QA supervisor, assistant QHSE manager in abroad. Currently, I'm working in Kuwait. It is in Damak Property Sister Concern. I have been lead auditor in ISO 9000, 22000, internal auditor in ISO 14000, 17025, and I am also a green belt for Six Sigma. Our today's agenda will be that first we'll see QAQC in food sector, then we'll see the PRP, then we'll see HACCP, hazard analysis and critical control point, then we'll see documentations and some auditing techniques and auditing details and the brief introduction for ISO standards. So before going further, we'll have some definitions. I need some input from you guys. So do you know what is meant by contamination?
Any undesirable organism present.
Yes, correct. Any undesirable organism, rather than I will say any undesirable thing into your food, it is a contamination. Maybe it is a physical, maybe it is a biological, maybe it is a chemical, maybe it is an allergen that you don't want to come into your food. So that is a contamination. So that is not intended for that particular food. It is a contamination. Then what is a hazard and risk? Can anyone?
Something that is dangerous for us, also for the product that we are manufacturing.
Yes, this is an hazard, and the risk is if there is any hazard. Let's say any hazard. Hazard is anything that is dangerous to your food and your consumer. But the risk is that when you quantify, that is the risk is called the degree of uncertainty, or the risk is an likelihood and severity of that hazard. When you means there is a hazard, but you quantify that hazard, then it is terms at the risk. Let's see what is the likelihood and severity. Likelihood is an occurrence, probability that how many times that particular hazard will come, and if it came, what will be the severity. Severity is an, we'll say, the impact to your food, impact to your consumer. Maybe health concern is there, maybe the risk of the spoilage is there. So when you that hazard, when you quantify that, it becomes in the terms of the on the scales of likelihood and severity. We'll see further that the likelihood and severity 3 by 3 scale, or it is called likelihood severity matrix. So that is a risk. So hazard is an anything dangerous to your food or a consumer or the process, and the risk is an uncertainty or degree of uncertainty on the scale of likelihood and severity. What is the basic difference between safety and hygiene? Let's say food safety and food hygiene.
Hygiene is cleanliness, sanitation, and safety is whether damage will, prevention of damage.
Okay. Yeah. Hygiene is actually carried out through cleaning, but hygiene is a maintenance of consumers or the food's health, so the people will not get sick. So all the purposes like the segregation of the areas, cleaning and sanitation, through which you are concerned about the health of the consumer, while the safety is to safeguard the food from the introduction of the hazard. So all types of hazards. So how you are taking the control measures, so that's why the hazard will not come to your in your food. So if you use the word food safety, it becomes that whatever the hazard or what are the hazards related to the food. When you say that occupational health and safety, so whatever the things that when you are doing your work, that is occupation. So what are the health risks are there? What are the health hazards are there? So you are managing there, then it becomes occupational and health safety. The same thing when you say the food hygiene. So you are taking the measures that when somebody eat that food, that people will not get sick. So that is a food hygiene. If you add the personal hygiene word, so you are taking the all the measures like cleanliness, bathing, nails, short nails. So in that terms, you will not get sick. So that is the basic idea, that safety and hygiene. And cleaning and sanitation that we already speak, but there is a basic difference between cleaning and sanitation. Does cleaning kill bacteria?
No.
So what it does?
It just removes the unwanted dirt or something.
Yes, correct. It removes the we can say the dirt or the biofilm, but it does not kill. Maybe due to removal, majority of the bacterial load is removed, but it is not killed. So for that, we need either disinfection or sanitation. That is in killing stage. That at this stage you are killing the bacteria. So sanitation is by using all the terms, by the cleaning age, by the disinfectant solutions, by the UV, or there are so many disinfectant or the killing agents that were that through that you can acquire the sanitation or the disinfection. So this I will not ask. So what is PRP, OPRP, CCP, and CL? But still, anyone has aware of the PRP, OPRP, CCP, and CL? Okay. See, PRP is called prerequisite programs. OPRP is called operational prerequisite program. CCP is a critical control point, and CL is called control limits, or the it is related to the CCP. So in that HACCP section, we'll see CCP and CL, OPRP also, and the PRP is a prerequisite program is all the basic requirements that you need before the start of the HACCP. So PRP deals with all the basic food safety, food hazards. Sorry. So PRP, I will give you some example. Like when you are going for the industrial production, you need plant, the location of the plant. Then you need the equipments, cleaning protocols. You need the water and ice safety. Then you need the personal hygiene training. All these are things you need it, and these are the basic requirements. So these are the PRP, where we'll go into details about the PRP. OPRP is an operational prerequisites. These are specific to that particular step. If there is a one step and there is a, as PRP hasn't taken care of the all the basic or the common hazards, now the OPRP is dealing with that only particular hazard that is on that particular step, and that control measure you are using on that particular step to minimize to that hazard to the accepted level, or you are completely removing that hazard. And the CCP is a critical control point. We'll see how CCPs are determined, how critical limits are determined. CCP is a core of the HACCP system. It is a critical control point here at this stage, and after that there is no any other step that is removing or minimizing your food hazard, maybe physical hazard, biological hazard, chemical hazard. Mainly, let's see the bacteria. So this may be the killing. Not only the CCP is not only the microbial killing state. We'll see that one. But let's for the sake of understanding, take it that the CCP is a microbial killing stage, like pasteurization, cooking, frying. So before that, there is no any step to kill the bacteria, and after that also there is no any step to kill the bacteria. So this is a very critical step where you are killing and you are making food completely bacterial safe. So like this, that's why it is very critical for your operation. So that's why it is called CCP, and it is determined by the CCP decision tree by using then before that we by using likelihood and severity. We'll see that one. Then critical limit. So the operational limit of the CCP decided. So let's see the bacterial killing stage. The temperature is like 71.7 degrees Celsius for 15 seconds, or then or the 72 degrees Celsius for 2 minutes. So this is a combination of one factor, and there is a limit. So this is a time temperature relationship, or the metal detector, like the zero 0.1 mm is the size. So this is the limit. Above that you are not allowed. So this is the limit that or this is the limit you have to work, like the freezing temperature -18, the cooling temperature 4 degrees Celsius. These are the limits. So the critical limits basically depends on your process validation, beyond the scientific evidences, and once you decided the critical limit, you have to decide your working limit also. So we'll go into details. Basic difference between validation and calibration, and I want to know which comes first, validation or calibration. Can anyone tell me?
Calibration.
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 Calibration. Why calibration comes first?
Calibration is the first step of validation.
Okay. Can anyone tell me what is a calibration?
If you everyone test, then first step is you to aware the instrument is calibrated or not. The specific value, specific number we can be used to calibrate the instrument, then to move.
Okay, Omkar, thanks. But see, calibration, basically I just want to give you basic idea. Calibration is related to the measuring instruments like temperature, your minute, then pipette, weighing balances. So all these are the measuring instruments or the equipment. What you are doing in calibration, that the calibration that you are checking, or rather than checking, you are correcting your equipment, whether the reading of that particular equipment is traceable to the national standard. Let's say that, let's take the example of the thermometer. Thermometer. So when you are say that my thermometer is calibrated, it means you how to prove that it is related to the thermometer which is present into National Physical Laboratory of India. So there is one thermometer which shows the reading. All the certification agencies, they have their master thermometer. They calibrate their thermometer with that thermometer, National Physical Laboratory, and then we are when we give our thermometer, they calibrate with their master thermometer, and then we get the reading. Now I will just tell you the what is the process. So because of this, we are maintaining, or the we can say the standardization. So if you say the I have 25 degrees Celsius temperature, so every thermometer around the India can have the 25 degrees Celsius temperature or the correct temperature. So that's to maintain that standardization. It is calibration is carried out. But what actually done in a calibration, I'll just explain. See, for example, you send your thermometer for the calibration, and with the master thermometer in the certification or calibration agencies, they get reading 25 degrees Celsius, and your thermometer get reading 25.1. So there is a number of texts are there, 1 2 3 tests, and but still you got 20.51 reading. So what it means, 25.1?
-1 is a error.
Yes. So in a calibration, we are calculating what is the error in our instrument. So we can, when next time you are going and when you check the temperature of any material and you got the 25.1 degrees Celsius temperature, you have to correct that temperature to 25 degrees Celsius, because the error in your instrument is 0.1 degrees Celsius. So that is your error. So in a calibration, you are calculating the error which is traceable to the national standard. So this is the calibration. So once you know that this is the error in equipment, so you can correct during the reading. Now we'll go to the validation. Hope the calibration is clear. Then we'll go to the
Yes, sir.
okay.
Yes, sir.
Fine. Then validation. See, validation, monitoring, and verification. Out of this, which comes first? Validation, monitoring, and verification. Out of this, which comes first? What do you think?
Monitoring.
Okay. Monitoring comes first. Yes. Actually, validation comes first. When in a food industry, the validation basically is generally everywhere. Validation is applicable to that particular step to identify that, for example, as everybody knows about the cooking stage or the killing of the bacteria. In a validation, we are validating or we are confirming that this stage, particular this killing stage, is properly, or does it give, or does it, you say, actual, does it conform to the our requirement? For example, you go to the research, you did the things that yes, 71.7 degrees Celsius is the killing stage. And for example, in your food, your target organism is salmonella, and the target temperature to kill that bacteria is 71.7 degrees Celsius for 15 seconds. That's your killing stage. Now when you go and you are performing the pasteurization, you should be sure that this temperature or this stage is attaining the 71.7 degrees Celsius for 15 seconds. So to we can say, to confirm that it is that particular stage, pasteurization stage, attaining this 71.7 degrees Celsius, whatever the things you are doing. So first, you can do the load test. You are giving the microbial load, the that you cannot do into the processing that salmonella. You can do that into lab. You will go that you contaminate the product. It is called load test, but it is generally done in a lab space outside to the food industry. You are going giving the load test. Then you are mimic the production environment, that 71.7 degrees Celsius temperature is attaining or not. That particular killing stage is carried out, and then we check after that whether salmonella is present or not. That is one stage that you can confirm that yes, it is killing. Or another thing is that you can just load the thermocouples or the data logger, which can take the reading for every 30 seconds, and then you process, or you just pass this data logger or thermocouple into the process, and you got the reading. Then you can confirm that yes, for this I'm getting this. Means for that particular killing stage, I'm getting proper temperature. So validation is confirming that that particular stage is attaining or is carried out its own purpose, or that particular purpose. I will give you just a little bit elaborate, because actually this, if once you have got this definition clearly, then we can fastly move on to our main core topic. So in a validation, what you do, once you got the temperature, that this is the temperature, then but during in a actual production, you have big pasteurization, you big fryer. In that, you have to maintain the time and temperature. For example, pasteurize for a frying, oil temperature is near about 200 degrees Celsius, 300 degrees Celsius. So that 300 degrees Celsius, then you have to maintain the time so that that particular temperature, that 71.7 degrees Celsius, should be attained. So for that, you have to carry out the belt speed. So what will be the belt speed? So that time I will get it. Then you have to determine what will be the ideal oil temperature, so the my product will be not overcooked. So all that things you calculate, you do the research, and then you validate that yes, this is the perfect combination. Yes, please. This is the perfect combination, that yeah, if I maintain this belt speed, if I maintain this oil temperature, I will get the 71.7 degrees Celsius for 15 seconds. Now you validate your process, you reconfirm this process by the third party. So this is the validation. Once you got that belt speed and the temperature, then your stage of monitoring starts. So what you go next time, rather than validation, you just check whether my belt speed is good. Yeah, my temperature is good. It means my temperature, I will attain the temperature. So monitoring it is a continuous checking of the set parameters. While the verification is cross check whether we achieved our result or not. For example, let's see, I have cooked something and I go outside. Sorry, I mean after the frying or after the pasteurization, I take my thermometer and I check the temperature, and I got the core temperature 71.76. This is a verification. So monitoring, verification of clear, and the, validation, monitoring, and verification. So validation, you decide the parameters here. You validate the parameter, means whether that particular my process step, my in during operation, whether my process step is acquiring that particular results or not. And for that I need a calibrated equipments. Then once I set that process parameters, I will monitor it, and after monitoring I will cross check whether the attended product or whether the process product got the results or not. So this is a verification. It can be carried out by cross checking, auditing, internal audit, or we can say the inspections. Now we'll see the basic difference between documents and record. What is a document and what is a record? Can anyone tell?
Records are made for future reference to identify mistakes.
Yeah, it can be used, correct. But the basic difference is a document. For example, let's see the thermometer calibration. So when you write the process, that when you will do it, who will do it, okay, how will do it. So that process,
That provides
it is
information.
called document. And then you take the reading and you put some reading, and now you able to know the what is my error. That becomes for the future reference. It is a record. So this record can be used for the future reference. So in record you put your information, like whatever you are doing monitoring, you put your information. So basic difference between document and record is record record of food can be used for the future, and documents gives you a guideline how to do that one. Non-conformance, let's see what is a non-conformance and non-compliance. I will explain directly this one. The non-conformance and non-compliance is a non-conformance is you have a standard. Let's see the food safety standard, ISO standard, HACCP, or any other client requirement. So when you are not fulfilling that requirement, any requirement, it is called non-conformance. When your product is unable to fulfill the major requirement, it is called major non-conformance or major non-conformity. And if there is a minor, that, like let's say you have a document, you implement it, and you have record, but you didn't fulfill the record, it will become minor. But you don't have a document, you don't implement, it becomes the major. But non-conformance becomes to your standard that you intended to do it. Means ISO, it's not mandatory that you should do ISO. It's not mandatory that you should go for BRC, you should go for any higher level of certification. So it's up to us, up to you, or it may be your customer requirement. But non-compliance is different. Non-compliance are the statutory and government or the legal requirements. So FSSI requirements are there. These are the compulsory requirements. Factory Act requirements are there. They are compulsory. They are it is the law or the occupational health and safety requirements for the employees. These are the compulsory must do requirements. And if you are not fulfilling that requirement or the government requirements or the legal requirement, it is called non-compliance. Okay. Can anyone tell me what is the difference between batch and lot?
Batch means minimum quantity.
Okay. Actually, okay, and lot? Fine. See, due to shortage of time, I will just go to their batch, lot, and traceability, and they are interconnected. Batch, lot, and traceability. If you see any product, you will see there is a lot number or any typical identification number. You saw the product, no? So you will see there different number like N19 dash dash dash, and it depends on the company. They have their unique identification number. From that they can able to know that yes, on which date it is produced, and who did it, which raw material, on which line. So there is an identification number, which is it is called lot. But that lot is made of few batches. So let's see my pre-preparation when I prepared my batter, or I prepared my raw ingredient for the production. It has a capacity of 200 kilogram, and I'm using it for next 2 hours. So there is a one time frame they have decided, or they have decided uh, like preparation. They have the mixers, the mixers capacity. So it depends on the company how they have decided. Some company decide batch on the time. Like for example, first shift, one batch, or they said one batch is in one mixer's batch, whatever it is, 200 kg, 100 kg, 50 kg. So that will be their batch. So multiple batches gives you a one lot number. So that is there is a set formula. That like for example, 4 batches, one lot, and this will be the lot number. So batch is an actual when you are doing in a pre-preparation, it is produced with a smaller batches. Then ultimately, for example, we'll take one example of onion bhaji. Then we'll elaborate all these things. So batches are have less quantity than the lot. So they produced. We can say, let's see. I have time limit. I decided the time limit of 8 hours, and in 8 hours, if I produce 1,000 kg, so in 1,000 kg, if I have 5 batches, so that 5 batches become a one lot. That documentation I have, that how they are connected. So that lot, when I got the complaint, or if I have to check for the traceability, so one lot, these are the 5 batches. From there, I have come. This is used for the traceability. What is the traceability? See, for example, when you take any item and you got the complaint, means like for example, you got the plastic piece inside, or you see it is not cooked properly and you made a complaint. So to make a complaint, when you make a complaint, the company will ask you what is a lot number of that. This lot number will help them to backtrace and forward trace also. Okay, where they have, means for example, if your concern is genuine, it is surely, and they check it that on this date, who produced it, where produced it, what was the temperature, is there any problem. So from that lot number they can able to trace back up to the raw material. So that's why it is a traceability, and you should have a proper procedure for the traceability. And even once they got, for example, properly know that yes, your concern is right, it is really undercooked, so they can forward trace also, that where it goes, not only this store, it goes to the 5 different stores also. So they can take the product back and reprocess if required. So the next concern is, or the next definition is, the product recall and product withdrawal. Product withdrawal and product recall. Product withdrawal is an voluntary, means if you are working in a company and you know that there is some lacuna for this particular stage, and there is a very minor, like for example, you are using two products, one with the MSG and another with the non-MSG, and you pack the product, MSG product, in a non-MSG packaging. So that is a concern, because in FSSAI requirement is that you have to mention MSG content, and you have to mention that it is not for the children below 14 years. So that is a mandatory requirement. But the product is a good one, so you can just voluntarily remove the product. You can we can say repack that product, or if required, reprocess that product, and then you can distribute again. So when you remove the product from voluntarily for your own mistakes, it is called product withdrawal. But the product recall is for a bigger scale. As I said, there is a, it's not cooked, or it has allergen content, or it has metal piece, or it has plastic pieces. So you have to collect entire food of that particular lot number, to your facility back, and you have to dispose it off. So that is the difference between product recall and product withdrawal. Then correction, corrective action, preventive action. Can anyone tell me the difference between correction, corrective action, and preventive action? Okay. See, corrections is that when you are, for example, during the cooking stage, you understand there is that particular item is undercooked. So immediately you uh, recook it again. It is called correction. But you do your research, or you do the root cause analysis that why this happens. Then you find out that there is a change in a belt speed, or there is a change in a flash point, or the boiling point of the water, or the oil. Then you understand that for that we need to adjust our belt speed, or adjust our parameter. So you understand that, and then you make that changes. This is called corrective action. So corrective action, and then you apply this to all other processing, that is called preventive action. So corrective actions or the corrections are taken when there is a, you got the non-conforming product. When you have a non-conforming product, so to correct that or to make it good, whatever the actions you have taken, it is a corrective action to avoid the hazard to pass to your customer. And once you understand the basic problem of that one, you apply that it should not come into the future for any other product. It is under whatever the necessary control measures you have done, it is called preventive action. So hopefully you guys understand this definition. We'll go to our basic core uh, course, that is the QA/QC. But before that, I want to tell you about the PDCA cycle. See, whenever you are doing anything in a food industry, you have to use the PDCA cycle, and that is nothing but a plan, do, check, and act. So even ISO 22000 is based, every ISO standard is based on this PDCA cycle. So what is plan? So if you are doing any test, you have to plan. So what is plan? You have to decide the procedure, you have to decide the resources, you have to decide what is the risk, what is the opportunities, then how you will do it, every other things. Once you did it, you have to do it. Then it give you a result. That result, that is, you have to check the pattern. You have to check what is the pattern. How? Yes. Here, this type of instrument is like this. But for example, you see this one particular brand of thermometer is showing a higher error. So you are checking that. So you got the inference, or you got the data that this type of data or this type of thermometer usually shows the higher error. So in the next time, what will be your action? So you will act it that replace this brand with this brand, and then same again, plan, to check, and act. So this is a continuous improvement cycle, PDCA cycle. In a ISO 22000, this PDCA cycle, there are actually, we'll go into detail hopefully, but what is my purpose to show you this is in an operation. See, for example, here you see in a plan FSMS, there are the 4, 5, 6, 7. These are the clauses: context of the organization, leadership, then planning, support, and in operation. Again, we have applied, or the ISO has applied, plan, do, check, and act cycle. So in that planning, we'll go to details of this one afterwards, but my basic concern, I want to show you that in this, in a food safety operations section, which is actually do section of the ISO, but we have to apply PDCA cycle here. So what is the, when you apply the PDCA cycle, what comes under planning? It comes PRP, traceability system, emergency preparedness, hazard analysis, validations, then HACCP plan, and verification planning. So PRP is a basic requirement, it has been told. Then traceability. Traceability system we have seen. Emergency preparedness. What if, that is a corrective action. What if there is an emergency, like if there is a simple emergency, like what if there is earthquake? What if your product is under good. What if there is a customer complaint? What if you got the allergens? What if? So whatever with the responses, so you have your procedures ready. Then you have to conduct the hazard analysis, validations, plan. We'll see in details. Then these are the do activities. Whatever you have decided, what then you understand what resources required. Then what are the risks? What are the opportunity? You actually do it. You carry out your verification activities or the checking activities, and you got the result. Then again, if there is any requirement in PRP, if there is any change in when you got the details from the checking activity, then you got the inference that yeah, if I can do this better, or we can do this better, or this is a new technology that can eliminate this thing. So this then can we need to change the PRP? Can we need to change the traceability system? Is there any new hazard? Okay. So for example, in up to last year, there was no risk of the COVID-19. But now there is a risk of the COVID-19. So for that need some basic prerequisite or the basic need. That is, we can call it here as PRP. So you needed some basic things like social distancing, or we can say the hand washing. So then gloves, mask. These are the mandatory requirements it has become. Then the transportation, the pattern of transportation change. Even we can say we'll go in details, but I just want to tell you that due to the COVID-19, there will be some change into the PRPs or the traceability system. Okay, now we'll see the basic requirements, but before that we'll go the foundation, that what is quality assurance and quality control. So can anyone tell me what is quality? We'll go rather than a difference between quality. Am I means my speed is good, or I'm fast forward?
Yes,
No,
yes, good.
No, it's okay.
Okay, so what is the actually quality?
Quality is in need of customer.
Yeah, it's a need of customer, but it is a
quality
requirement rather than a quality.
quality is the process of the food packaging within which they can be used to provide the very pure and very healthy products to the customer.
Okay, okay.
Quality
Yes, please.
measure of excellence.
Yes, it is. We can say that. I will give. Take one example. Like, everybody knows onion bhaji, right? So onion bhaji in this monsoon season we are preparing. So what do we need? We need a gram flour, chili powder, coriander powder, cumin powder, salt. Then if need the turmeric, and then water we mix in water and we'll just fry it, cool it, and eat it. I just want to ask you that if I prepare today, if I prepare tomorrow, if I prepare day after tomorrow, does I get the same taste? Does I get the same flavor?
No.
No,
No, sir.
Why? Why?
the process sometimes changes.
Yes. So can I say that my product is of not good quality? Because if when we go to the hotel and if we like the dish, that taste, that flavor, that we keep in mind, and when next time we go to the same hotel, and if there is a slight change in that taste, we say, now it's not of good quality. The quality has been changed. So we tell our people, tell our friend, यार अभी quality change हो गई इसके क्या प्रसिद्धि इसके दिमाग में चली गई, ऐसे बोलते हैं. So that's the thing. So quality is a degree of excellence. Someone actually communicate that. So it's a degree of excellence, but it is for that product. There is a characteristics like size, shape, texture, flavor. You have to prepare. You have to give that consistently of excellence quality. You yourself excellence quality or into in improving. You have to be better than the before. So like as I said, the characteristics like size, shape, texture, weight, flavor, then aesthetic value, color, all should be of a consistent quality. These are all called as quality characteristics. I want to ask you, who gives this quality criteria? Or this is called quality criteria. Who gives this quality criteria?
I
Consumers.
also
Who gives this quality criteria? Consumer. Okay. Another? Any other?
ISO certification.
Yes, correct. If you are
FSSAI.
going, sorry.
FSSAI.
Yes, correct. Good, good. So first, the consumer gives you quality criteria that I want like this, like this. Then there is a basic requirement from the government or the governing body or the it is called statutory and legal requirement that your food should be like this. And if you are willingly opted for the certification like ISO certification, BRC certification, then there is a criteria that you have to perform like this. So quality criteria you get from these three things. Now we'll elaborate our example of onion bhaji. See now in our kitchen we can prepare like this. Let's see. Now we have to go to industrial scale. You are a very good in onion bhaji. Now you want to prepare that. You see, means if somebody tell that you can go for the industry, then you do the online campaigning. You go for the YouTube influencer. Then you go to the Instagram influencer. You do the Facebook ad, Google ads, and now you have or you do even networking also, and you got like for example 10 lakh customers, and they are ready to take only 100 gram per month. So then we'll just do the some calculation. See, you have 10 lakh customer, they can able to give you or they are willing to take 100 gram so per month. So how many grams you can able, near about 1000 lakh grams you have to prepare per month. So let's convert them into kg. So 1 lakh kg per month. But how you will produce in a month? In a month, if you are going, there is a 4 days off. So for industrial scale, so 26 days working. If you say if you are producing on 3 shift, then you have to produce 1 to 8 near about 1282 degree, sorry, 82 kg. And if consider the one shift of 8 hour, let's see that there is a lunch break, so the shift is for 7 hours. So every hour at least you need to produce 183 kg. And for the production of 183 kg, at least you need more 25% more capacity. So you need a equipment or the processing facility of at least 228 or 225 to 250 kg. So you need equipment, they can process your product hourly. So let's see, we need an onion. So it's an inhuman to cut the onion near about we say the if you consider the even 25% of that like 50 kg per hour, it will be inhuman. So you have to do, you need to use machines. Now let's stick to our definition of the quality that you should you you need a same texture, you need a same size, then you need a same flavor, you need a same aroma. So to on which it will depend, it will depend on your first on your raw material. So you need a raw material that is of a consistent quality. So you go to the supplier, you tell them that I need such a type of gram flavor, this and this only gram flavor, but you need, let's see, near about per hour you need more than 50 kg. So let's say for per month it will become near about 50,000 or more. So like this you need that big supply of the same quality. Same goes to the onion, you need have a same slices. So the human cannot prepare that one, so you need a machine. So you need that spec, how that machine will cut it, how will they, then to have that particular same taste and same flavor and the same size, you need a recipe. In home you don't have recipe, we're not following that 1 gram this, 1 gram this, we're not doing it. But for industrial level we need a standard recipe. Then that how much, this kg of onion, this kg of flour, this gram of salt, then like this. You need a standard recipe. Then you need a standard quality of water. Now water, which kind of water? Either MIDC water or the groundwater. If it is a groundwater, it should be have consistent quality. Even MIDC water is not of consistent quality, so I should need a water processing for that one. So I need a water processing. So and then I need the specification that it should be bacteria free, it should be chlorine residual should be like this, then TDS will be, or the hardness will be like this. So that one, so water will not affect the taste. Now the mixing time. So every time you will have to mix it properly. So you need a machine, like for example, how many kg? 200 kg or 250 kg per hour. So you need a machine of that size. You can able to do the cleaning, you can able to handle it, you can able to use it. And then you need a mold that will give the same size of the onions. Then you got the big size of fryer that will fry that item, or that will kill your bacteria, that particular quantity. So you need a fryer. Then if you go directly to your for example selling after frying, there will be problem because it has a shelf life only for 1 or 2 days after frying. So you go for either for chilling, but chilling is also again a problem because the shelf life will be only 1 month. So you will go for the freezing. The freezing, then you can go for up to 1 year shelf life. Then there is a packing. Here you need a labeling. So you need to decide how my date coding will be there, so I can able to trace back or the trace future forward. Say then you need a packaging equipments, labeling equipments, or the coding equipments. Then you need, as you are using all the machines, you need a metal detector, and this is a huge quantity, and it is a monthly requirement only. So you cannot go, or even transfer for 1 kg is not cost effective, because for it's like an when say the uh, for 1 kg of there is actually one term, but it's leave it. So it's not a cost effective transfer of the small quantity of food. So you need a big container. So before that you need to store it. So and then transport, dispatch, and then display, and the consumer will pick up. So we'll just review it. You need a receiving, or we need a raw material. Then you need a receiving procedure. Then you have to store it properly. The raw material have high bacterial load. Finished storage and raw material storage should be different. Then you go for the pre-preparation, where you need exact sizes, or exact sizes of the onions, exact quantity of the items. Then you go the mixing time should be perfect. Size of the onion per should be perfect. Frying time should be perfect. Then freezing time should be, after frying you have to do the cooling, otherwise freezing will be not effective. So there will be one cooling, then freezing. Then you have to do the packaging and lot, or the labeling for that one. Then you have a storage, free obviously if you are going for frozen storage. Then your dispatch and display. So up to the storage, what you did to get what we call it is a quality criteria, to achieve the quality criteria, you standardize everything that affect my product, or that affect the onion bhaji. Everything, raw material, the size of the onion, mixing time, ingredient details, frying time. So this is a basic requirement that you need. So these are the requirements. So this is the quality. This attaining to standardize the everything to achieve the desired result consistently over the time, or you are excelling in that one, it is a called quality. Now what is a quality assurance and what is a quality control? See, for the quality assurance, for example, let's start the like raw material. So you go, you you decide I want this type of gram flour, this type of onion. So from here I will collect. We told them how to prepare it, how to produce it. Don't harvest early, don't harvest late. So I want like this quality, like this. Then um, you made a raw material specification for that. You communicate to your supplier and you prepare it. So all the things from raw material, you Same things you apply for the preparation. You communicate to your employees how to do it hygienically, how to cut it, how you are going prepare the recipe. Then you apply the same thing, that how you need these things, and you are continuously set one specific or specify the criteria that I need this one, I need this one, or let's say the labeling, I need this type of packaging material. So you didn't need a you set a criteria there. So this is called quality assurance. You are assuring that at each stage, whatever our quality criteria is attaining. But in a process, so you understand the quality assurance, so I can go for the quality control. Or is there any doubt?
No, sir.
No, sir.
Fine. So now you are deciding the, you are specifying the requirement to attain your criteria. But let's see, at the condition of batter, at the batter you prepared the batter and now you are going to fry it. But I have doubt whether there is a extra salt, or whether that particular consistency there, or whether it is tasted. So that time when you check, you set one tests, like different types of test. You can go, you can just test it. You can, so this is called the sensory profile or the test profile. You decide the test profile. If this test is like this, like if it is, you need a like spice should be like this, texture like should be like this, or the like pH, moisture content. The moisture content can decide that, yeah, it may have a higher water, so that gonna future affect the taste. So all these cross-check techniques or the cross-checking tests are nothing but quality control. So I will just elaborate once again. The quality assurance, or the definition of the quality assurance, is from raw material to finished goods, you are deciding the operational specifications to attain your quality criteria. This is nothing but a quality assurance. While during the operation, after particular stage, you want to cross check whether I have achieved my desired quality or not. To perform that, or to check that, there are different tests. These tests are conducted through the quality control. Hopefully you got the idea of quality assurance and quality control. So this QA is nothing but control at each stage in a food production, from raw material harvest to the final consumption. While QC is a series of checks and control measures that ensure that the uniform quality of food is produced. So it is an operational techniques, while the QA is a planned technique, systematic approach. Okay, it gives us a confidence that yes, we have prepared, we are doing what we set as a quality for ourselves, and that QC is doing checking whether we achieved it or not. See, in QA QC we call it, QC is a post-mortem. Once it is produced, we check whether it is attended or not. And in QA, it is an ante-mortem. So during the process, so QC is a part of QA, QA is a part of QM. So QC, in that we are meeting our whether we check whether we meet our criteria or not. But QA give you that yes, we are doing it what we have decided. That is confidence that quality requirements are being met. While the quality management is a coordinated structure that we can say the ISO 9000. So it is a customer focus. We say we take the criteria, as we discussed, take the criteria from the customer, we take the criteria from regulatory body, we take the criteria from the ISO standards. So this complete, to attain that complete system, it is a QM. So QC QA is a part of QM. So there are few tests. I'm not going to into details because see, in a food chain or in a food industry, there are different types of food industries. So let's see, if you start from agriculture, every food is start from the soil. So if you want, you can make an industry of the fresh fruits, or you can make a industry of the grains. Then it can go for the only milling, only powder form, flour form. That can be a different industry. Then processing industry can be different. Ready food item can be different. So every industry is a different. So for every industry, the quality assurance and quality control isn't different because their scope is limited. For example, for fresh fruit and fresh vegetables, they have very simple stage, like only clean, sanitize, and pack the food and lot number and just go. So they will have a simple quality assurance and quality control. But if you go for the processed food, ready to eat item, you have different stages. You have raw material, you have processing, which is a complicated processing. So you need to do the complicated test. You should have a different quality assurance protocols. So you have to understand the basic idea that I have quality criteria that is called product specification. I want to achieve it. This is my customer requirement. This is a legal requirement, and this is a ISO requirement. For that, to achieve it, that I need some processes or the specifications or specific criteria to achieve that particular things. That will becomes my quality assurance. And to cross check whether I am doing it properly or not, it becomes a QC test. So QC test can change to different industry. Quality assurance can change to different industry. So it depends on the industry. Now let's see the QC test. It can be test profile as we seen on in Bhaji example. Acidity measurement. It is titrable acidity. So you can check. There is a difference between titrable acidity and pH. So pH you can check. So pH can affect the taste. Moisture content. Moisture content gives you water content. Then sugar content, protein content, ash content. See, there is a purpose behind this every test. For example, test profile. So you know that you are giving the consistent test. Acidity measurement on the pH. Sometimes some item have a higher acidity and some don't have. Some should be go for, like say, water. If your product is water, the pH should not be to the acidic range. Otherwise, test will change. But you are providing the pickle, the pH should be acidic because it is one of the, we can say, preservation technique. So that you are checking whether I am achieving it or not. Then moisture content. Moisture content in a pre-processing give you idea that whether my battery is of good quality or not. And afterwards, that it can predict your, we can say, the spoilage or the shelf life. Sugar content. Because of the nutritional profile, you have to give if your product is glucose based or the sugar based, you can get the idea that this much sugar is there. It means yeah, this will be the good quantity. Or the protein, ash content. Then microbial test, you know that it indicates to it is an indicator. There are microbial indicators, and there are requirement that pathogenic bacteria should not be there. So we'll go to the pathogenic bacteria afterwards, but in a microbial test, there are some indicator tests that will be useful in a QC, like Staph aureus. Staph aureus is an indicator of sanitary condition. E. coli, it is a contamination of fecal contamination. So you get, or even I think Streptococcus faecalis is also an fecal indicator. So you get the idea that this means this. So if you got the Staph aureus, it means there is a problem in cleaning. If you got in E. coli, there is a problem in your water. So like this. So viscosity, some item need a viscosity. FFA level. FFA level is a free fatty acid level. It is for the frying oil. So if your oil exceed that FFA level, one thing is there is a for all the time it is a risk of cancer. Then another, FFA give the rancid taste to your product. Means if you oil got burned, so burn, then the taste of the product will change. So FFA level is an indicator that this is the time to change the oil. Burst test of the master carton. See, if your carton is 10 kg, so it should be able to sustain that 10 kg throughout the transportation. So how to check it? So there is a burst test. There is a one equipment that per grammage, they just burst it. So upon that, we can able to calculate how much kg it can be at. Gluten test, same goes for the protein or the wheat protein. Brix again another to check the sugar or the sucrose mainly. Chlorine residual mainly for water, you need it, or that I want below that one chlorine residual should be. Higher the chlorine, it can impact, or it can, because the chlorine has a nascent oxygen, so it can interfere to your ingredient. Then water hardness. So it depends on your product. For example, beer, they need a typical type of water. So beer industry is basically located to the water which is rich in calcium, magnesium, because it gives some different types of taste. But for normal food processing, the water should not be hard. Another shelf life analysis, that how much I can display that the consumer should consume before that one. So before the production go to the display, you should have to do the shelf life analysis. Now it is a mandatory requirement for the nutritional profile, but it depends. Nutritional profile is an display of how much is carbohydrate, protein, fat, if there is any vitamin, salt. It's so people can choose their product depending on the nutrition for the basically mainly for the health concerned people or the healthy lifestyle people. But nutritional profile labeling, it comes part of the labeling. So that one, it is a third party analysis. Actually, residual toxic contaminant, pesticides, heavy metals also third party. Then benzoate analysis, preservative analysis, third party. Migration test for the packaging material. Does packaging material contains any toxic contaminant? So it is called migration test for the packaging material. So that comes under QC, but last four tests are third party generally, because the equipment required for them is quite costly. So basically it is carried by third party, or we can say the labs. Third, ISO 170 or NABL accredited 17025 accredited lab or NABL accredited laboratories. Okay, then few QA inspection procedure that we have seen, like supplier approval, raw material spec, receiving and storage procedure, then recipe, processing specification, what is the labeling requirement, packaging guideline, date coding, what are my GMPs, GAP, GDP, GHP, GLP. See, GXP, that's why I use it. M for manufacturing, or the GMP is a good manufacturing practices, good agricultural practices. GDP is a good distribution practices. GHP is good hygiene practices. GLP is a good laboratory practices. So what is storage and transportation? Sorry for that mistake. Transpiration. Okay. Then customer complaint handling, corrective and preventive action, root cause analysis. What will be my finished product specification? Then what will be the release procedure? That if there are some release procedures, like for example, if microbial tests good, then it will be released. So that will be the release procedure. Then who release it, or what is authorization for release, then HACCP ISO requirement, authorization safety, air safety. Generally air is controlled by air handling unit, which is generally pass through the HEPA filters, so air cannot act as a contaminant. Cleaning procedures, pest control. Okay, do you need any QA inspections procedures to elaborate?
No.
Let's see our onion bhaji example here. So what will be the quality assurance, what will be the quality control, what will be the document, and what will be the record at the receiving and storage. So what will be the quality assurance? Supplier approval and raw material specification. Then we need to do the vehicle inspection, FIFO and FEFO. When you are going for the storage requirement is there, but you need to do it is comes under good storage practices. So that you have to decide whether you go for the FIFO, first in first out, or first expiry first out. Then labeling requirement, that in a labeling requirement it is unprinted information on the food package. Here it contains your logo, pictures, graphics, then it contains your ingredient details, nutritional labeling, if it is a new or unique product, how to prepare it, the preparation methods, then your contact details, your license details, your registration details, other things comes on the printed. You have to check it. There should be a procedure that I should check it. If there is allergen information, that also comes here in. So every time when that printing material came, you have to check it whether there is any mistake is there, whether there is any we can say printing error is there, or whether any information is missing. And another, to decide that packaging material, what kind of packaging material that you require. Then good storage practices, cleaning and sanitation of the stores, which is applicable to entire food processing facility. Then personal hygiene of the staff, which is working in the quality assurance. Then quality control, what test we can do to check that what we have decided in a quality assurance that we are doing it. So let's say we decide the raw material specifications. So we check it whether it attend this physical, chemical, microbiological criteria. If it attend, we can go for the release. So you can receive it and means we can go for the release, means release into production. Then for master carton burst test, swab testing of the employee to check their personal hygiene, water testing to check the sanitation, water because where that water you are using, we can go for even disinfectant efficacy test in quality control. Then which kind of documents will get there? There is a difference between document record you can see here. So RM and PM specification will be your become a document. Supplier approval program and will become your document. Then procedures like vehicle inspections, testing, physical, chemical, microbial, all the testings, procedures of that testings. How you'll do the inspection, that is a procedure. How you'll do the testing, how you'll do the release or the reject. If release, if the raw material is of good quality, or we can say the conforming to your quality criteria, you will release into production. If it is not conforming to your quality, or if it is not acceptable, you will reject it. So what will be the procedure for acceptance, rejection? How you will store it? Because let's say in a case of onion bhaji, you need a oil, you need a flour, you need a onion. So onion you need a chilled storage, other dry item need a dry storage. They should be then segregated. Then they can go for the FIFO that you need to decide. So this is the procedure. Then how you will do the cleaning, how your water safety, how you are going to, let's see, cleaning. I will use this type of cleaning agent into this percentage. So you need to give the protocol. Then sanitation, then water safety, how what type of water filtration you will use it. So this everything you have to write down into procedure and the personal, even in for the personal hygiene also. And the record will become approved supplier list, vehicle inspection record, test records for the physical, chemical, and microbiological analysis, then release and reject record, then receiving, what quantity you received, what is the lot number of that one, or then where you store is, that is a storage document, and the cleaning and sanitation document for that store. Okay, you got the idea?
Yes, sir.
Now, actually, there is one homework for you guys. As we see, in case of onion bhaji, this is just for the first step, like receiving and storage. Do a homework for this one. That let's see, the next stage is the preparation. Next stage is the mixing. Okay, then mixing, and then next stage in a preparation there is a recipe. Then there is a mixing. Then there is a frying and cooling. Then freezing. Then packaging. Then storage, and then distribution. So at home, please do this exercise, that at this stage, what will be the quality assurance criteria required, what will the quality control, what will be my document, what will be my record. So do at this homework for all the details, because we have a way, means already I think we have a short of time, because we need to cover so many things. I cannot go into details. Okay, so please do the homework for this one. Now we'll go to our next point, that is a prerequisite program. PRP. That is in case, let's see, we are now we are using the onion bhaji example throughout, because see, I already told you that there are different types of industry. So you cannot apply the same structure to all the industries. There depends on the industry. But now we have elaborated our onion bhaji example. We'll take that example and we'll elaborate our all concept to that example. So find the PRP, prerequisite program, in an onion bhaji from kitchen to industrial level. What do you think? When you want to go to the industrial level, you need that things. Can anyone tell me that you prepare in kitchen? That's okay, but as we see, we need to prepare how many kg? We need to prepare near about 228 kg per hour, or we can say the 1200 kg per day. So we need to prepare near about 1200 kg per day. Now you want to go to the industrial level. What things you will need to go for the industrial level? Can anyone tell me? Just try to.
Uh,
Yes, please.
the machinery,
Machinery, right?
then the electricity for the equipment,
Yes, electricity for that equipment's correct.
And power.
Manpower.
Manpower is required, correct. You need more manpower. Okay. Any more things?
Raw materials.
Raw material, consistent quality of raw material, correct.
We need to scale up.
Yes, we need to scale up, but we need to scale. We need to do our R&D. We how to prepare recipe, correct. But that is a part of the R&D. But now we have to go for the industrial level. We need a basic requirement. Our scale up is done. Now we are ready for production. Yes, guys. Marketing, yes, but actually we concerning about the production only. Now for a production, what we need? Standard, okay, that will be our quality criteria. But see, that's why, because we are so concerned about the output, we forgot about the basic things. See, now I will elaborate. If anyone have any another answer,
Large area.
yes, that's the first thing we need. Correct. That's actually I'm expecting the answer. You need a plant. First thing you need a plant where you can do this process. And there is a requirement for that plant. It should be accessible to the road. It should be big enough that so you can do that different area, like you need a raw material storage, you need a raw material processing, then you need a fryer, freezer. So the material handling should be proper. You need as someone tell, we need equipment. So the equipment is such that per hour it should be 250 kg processing. So you need that big equipment. So you need such a big plant. We need to manage that material. We need to manage people. So we need a plant. But plant where we can access a road by water or by any accessibility by road or water, by rail, air, any accessibility should be there to the outer environment. Then we need a water, and we need a electricity, we need a proper have existing. Then we need equipments. So we need equipments that is suitable for our purpose. We can able to clean it, we can able to dismantle it, and we can use it properly without any disruption. So that is our basic requirement. Then someone tell you the people. Yes, we need a people. So we need a people. Then we have to communicate them. That is this is the product we are gonna tell. We are gonna produce. So we need the training program. Then once you produce the product, you need a lot details. So you need to decide how I can trace my product in under the emergency. If there is any emergency, if there is any customer complaint is there. So how I will handle the customer complaint? How will be my traceability? That you need it before the production. Okay. So whatever the for processing what you need a frying. So you need a fryer. Then you need a freezer. So that freezing requirements are there. So if you go by one by step, you will able to know that my basic requirement will be the plant, then manufacturing protocols, equipments, people, their hygiene, their training. Then I need a traceability program. Okay. Then I need some the safety of the factor that's basically affecting to my food. That is a safety of water and ice. Okay. The cleaning conditions, pest control is there. Pest can affect my quality. Waste disposal is there. If there is any generation of waste, then waste disposable, it means drain, structure of drain. So my plant should be accessible to the drains. So these are the prerequisite things that is required to go before the HACCP, before the hazard identification. You must need these things. So these all are prerequisite programs. You got the idea about prerequisite programs?
Yes, sir.
Okay,
Yes.
good. So PRPs are the basic requirement. Basically, it is called GHP or the GMP and SSOP. So good manufacturing practices and sanitation standard operating procedures. That is an SSOP. So these are the GHPs or the PRP. So PRP is a combination of GXP rather than H. I will say GXPs. All types of good manufacturing or good practices and standard sanitation operating procedures. Then this PRP make a good foundation for the HACCP. Now then you can use the HACCP principles. Then you can use the HACCP principles and you can implement your HACCP. So you can, because in a PRP, I will go there, but I will just elaborate this example or this diagram. Principle GHP is a foundation for HACCP. Once you have HACCP, you can go for the quality management system, that is any ISO, and then you can go for the TQM, which is a part of culture. Some company has a quality culture. We say that. So it gives. So this is the flow. So TQM concept, quality management concept, HACCP and GM or the PRP. Until now, do you have any doubt? Okay. So sure. Actually, I am unable. There is some pop-up, so I'm unable to see. PRP. So I already told you, PRP is all GXPs. They are needed depending on your food. I already told you previously that different food industry has a different structure, different requirement. So PRP, maybe few industries. For example, let's go by the GAP. Good agricultural practices. Do you think where it will be useful? In which industry it will be useful?
Agriculture.
Food industry.
Which industry? Sorry,
Dairy industry.
dairy industry.
Agriculture.
Agricultural. I mean, basically, let's see, you are selling your food is a raw material like a raw fruit or raw vegetables or the frozen vegetables. So you need a good agricultural practices there. Or let's see the wine industry. Wine industry, they are preparing many wine industry, they are preparing their grapes. So they need a good agricultural practices because it's going to impact their food or they impact their product. So where the good veterinary practices will be applicable?
Poultry.
Correct.
Meat
Poultry and meat industry. So good veterinary practices will be applicable there. So same way, good manufacturing, good hygiene, good production, good distribution, they are generic. Good trading practices, it depends on the type of your industry, but that's okay. So this is PRP. So PRP mainly, yeah. So PRP mainly consists of GXP and SSOP. So what is a GMP or basic difference between GMP and GHP? GMP is a good manufacturing practices. GSP is a good hygiene practices. So we already saw the manufacturing. So what for the manufacturing? What are the good practices? So this is made by the expert that if in our in during the production, uh, the specific criteria that we want to attain or the specific parameters that we want to attain. So we make one procedures like storage will be like this, distribution will be like this, preparation should be like this, plant will be like this. So this is when you set a standard criteria, it is called good manufacturing practices. To produce a product or to manufacture a product, what are the set practices? It is called good manufacturing practices. Or these are the procedures for a particular manufacturing operation which practitioners or generally the industry and experts in that operation consider to be the best available. While the good hygiene practices, yes, please. Someone raise the hand. All practice all practices regarding the condition, good hygiene practices. We already know the what is hygiene. Hygiene is that it's in practice or it is in procedure so that your food and the consumer should not get sick. So all the things mainly related to cleaning and sanitation. So all the practices and the conditions that measure the necessary to ensure the safety and suitability of the food at all stages in food chain through the cleanliness and sanitation. So there are some see codex WHO or NACMCF. They give us a definition or they give us what is a prerequisite program. So everybody, including Codex Alimentarius or Alimentarium, then WHO, World Health Organization, NACMCF, and yeah, actually there is a ICMSF also there, but we'll go there. So NACMCF is a National Advisory Committee on Microbial Criteria for Foodstuffs. They play a very good role in a development of HACCP standards. We'll go there. So everything, these are the independent standard providing bodies. If you go to the codex, you will get a lot of information. WHO, you will get the information. NACMCF, these are the very good resources. But everybody says these are the basic requirement prior to the application. So what codex says, prior to the application of HACCP to any sector of the food chain, that sector should be operating according to the Codex General Principle of Food Hygiene, the appropriate codex codes of the practice and approach. So prior to the application of HACCP, then WHO, practices and conditions needed prior to and during the implementation of HACCP. While the NACMCF, procedure including GMP that addresses operational conditions providing the foundation of the HACCP. So PRP is required before the HACCP. So what is GMP and what is SSOP? We'll see it. So GMP and SSOP put together becomes the PRP. So what big are the PRP? These are the plant, location, environment, infrastructure, design and construction of equipment and utensils, hygiene control, personal hygiene and health, traceability programs, training, preventive maintenance. So plant location, environment, we already saw, design and construction of the, we can see only we saw the plant, but you see if you plant location and environment is means outside your industry. It should not be near the dirt or the dust, and or your waste disposal should be such a way that it will not attract to the insects. And infrastructure, see, we cannot use our cement walls when during processing, because cement has different heavy metals that can leach into your product. So it should be a particularly, that is puff panels, it is called, the material that is prepared for the processing plant. If you go and observe, it is a different, it is a polyurethane foam is there. So it is a puff panels are used, which are heat resistant, which are the fireproof, which are cleanable. So any material, I'm just giving you an example of puff, but any material which should be cleanable, which should be heat resistant, which should be chemical resistant. Then floor should be that it's slip proof. You cannot it should not be slippery, because water will be there. You are doing cleaning, so it should be slip proof. It should of light color. Then it should be suitable for the purpose. It should be hard. Even it is easy to replace. You will have a drain. It should be a closed drains. Your drainage should be system should be such that there will be a wall to block the backflow. So between some block in a drain, there is a block. There should be a backflow wall, so it will not come back to your processing. So like that, you need into infrastructure. Then to your panel, it shouldn't. There is no any window, because direct air should not come inside. So internal air should be handled through the HU, or whatever. If air is coming, it should come filtered. Then lights, take anything that there is a specific criteria. Light, so light should be there, proper light should be that. The top light should be covered. So if there is a breakage in a light, it should not come to into your food. So if there is a cover for the light, then there should be a segregation of the areas. So, and there should be a straight material flow and man flow. Raw material people will work in raw material, finished good people will work only in the finished good. So they decide the high risk area, medium risk, and low risk. So low risk people work in low risk, high risk will high risk, moderate risk will work in moderate risk. So that way you need a people. Then design. This comes design construction of equipment and utensils. You need a equipment that should perform their intended purpose. And if you are using a fryer, it should do the fryer for 20 kg per hour. So you need that machine. So you have to specify that one. After that performing the operation, you can able to properly drain the oil, or you can able to dismantle it. You can properly clean it, and you can able to pack it properly within a very short time. Then your material, that is, it should be, it cannot erode it. There is a food grade material, quality, I think S302 is a standard that should be a food grade steel. If you are using a plastic, it should be a food grade plastic. If you are using a sanitizer, it should be a food grade. So even your machines, so processing machines, cleaning equipments, that can able to properly clean and use, and it should be for that intended purposes. Then hygiene control program. These are the procedure for cleaning and sanitation. So cleaning, you can use the different types of detergents. So you know the percentage actually, and you know the disinfectant. So which kind of disinfectant either you are using chlorine, either you are cotton ammonium iodophore, or you are using we can say ozone, or using bleaching agent, or any gaseous agent like formaldehyde, or the fumigation agent, or hydrogen peroxides. What kind of disinfectant you are using, or the sanitation things you are using, you need to know the disinfectant efficacy test. What is the percentage? Because higher the percentage, it can go to the leach into the food. So what is the percentage? Like for example, 6% of that chemical for this time will kill all the bacteria. So you have to carry out the disinfectant efficacy test, and then you have to give the protocol. So hygiene control programs are there. Then hygiene control programs depends on the area. Raw means, for example, high risk area need hygiene control program, like positive airflow is required, so that through years there should not be a contaminant. Then for low risk area, there is, if there is any lacuna, or mean there is not required of the positive airflow. So likewise, you need to determine area wise hygiene control program. Personal hygiene and health. How you will determine the health of your employee? So if you go now, actually you will go to the industry. First they will do your medical. They do your medical because there is a set of diseases, there are a set of things they will check, whether you are means you have high BP, or you have any cardiac issue. So whether you bear the pressure of their industry, whether you have that particular microorganism that you can carry. So if you are okay, so in that way, health screening is done. And there are personal hygiene protocol, like short nails, short hairs, then hairnet, mask, separate apron, separate gum boots, or the shoe cover. These things comes under personal hygiene. So that you need it, you need to decide. Traceability and recall procedure, I will not explain it again. We have gone through it, but it is related to the lot and batch, and how to you trace back under emergency. Training. When you hire new people, you hire basically a competent person that you know that he can do it. But every organization is different, so you have to train them for that their purpose. If they are operating CCP, you have to train them for CCP. For example, when you go to the industry, there will be induction training. Induction training will be that, so you will go to the different areas, and you will able to know that this is my plant, this is the operations are they are doing here. And then when you go to your specific operation, you have been trained. The training can be internal, training can be secondary, training can be from third party, like a certification agency. Preventive maintenance. Do you know what is maintenance, preventive maintenance, and the types of maintenance? At least two types of maintenance are there. Can anyone tell me the what is maintenance? And I want to ask, if I go fast, just let me know that I'm going a little bit fast. Okay, please. Hello, guys.
If any equipment is damaged, so a maintenance engineer or some person should be there who can maintain or who can correct the instrumental error or some kind of if an
Yes.
instrument has been damaged or
Yes,
something.
yes. Let's see. In a home, we are using mixing, and you use a high load, heavy load than it required, and now the wheel of that or the spinning wheel broke down. So this broke down. It is called breakdown into maintenance, because you overload it, or you do not follow the procedures the way it should be followed. So now the equipment cross its limits, and now it is a breakdown. So it is called breakdown maintenance. Is there? So that is actually a big problem, because when you are doing your production and suddenly the instrument break down, then there will be the lag. The production will halt. Whatever the process material, it not able to get that treatment. There is a risk. So you may have to throw it. So it's better go for the preventive maintenance, weekly, monthly, yearly, internally, or by hiring special agency. Check on a daily basis whether my instrument equipment are they performing well or not. If there is any indicator, so in a meantime, before happening the breakdown into breakdown maintenance or the breakdown of the equipment, I will repair that one. So all these procedures like electrical, mechanical, refrigeration, all these things are there. It's a complicated environment, machinery environment in a food industry. So you have to check one by one. So electrical department will check electrical aspect, mechanical department will mechanical aspect. So such a way that you check whether that equipment is performing or not in advance before the breakdown. It is called preventive maintenance. We'll go for the SSOP, that is a standard sanitation operating procedures or sanitation standard operating procedures. You can, because it's a double S, you can use anything. In that, there is a safety of water and ice, condition and cleanliness of food contact surfaces, prevention of cross contamination, maintenance of the or the personal hygiene, protection from adulteration, proper labeling, control of employee health condition, and exclusion of pest. Out of this, we have, I think, I talked about the cleanliness. Then we talked about personal hygiene. We talked about labeling, but still we'll go there. We talked about the employee health condition. So I want to, we'll elaborate a little bit safety of water and ice and how to write the standard operating procedures. And I'll just give you idea. But here I want to ask you, why the exclusion of pest? Why pest is a problem in a food industry?
Because the pest is the host of any microorganism, pathogenic
Correct.
microorganism.
Yes, they can be the host for the microorganisms. So how to control the pests? First thing, in a vicinity there should not be any wastage, so that will attract your pest. Your processing industry will be such that there should not be any gaps, so the pest will come. You can use the repellent, you can use the killing agent. So if you go to any food industry, there will be the airflows. When you open the door, there will be the airflow. So to break the airs, so the flies will not come. That's one of the purpose, but basically it is an outside air should not come inside, and that can act as a contaminant. But it again used for the exclusion of pest. Then where there will be the rodent traps are there inside, there will be the different types of the repellents are used. So it basically is an integrated pest management. Generally it is done by third party, or the sorry second party. You company hire someone to do these things. Then proper labeling, storage and use of toxic compound. First thing, chemical cannot be stored in the food processing industry, like near the raw material, into the raw material. So there should be a separate area for the chemical storage. Whatever the chemicals are, should be separately stored. They should locked every time, and the key should be with the authorized person only. So authorization should be there to use the chemicals, because higher the quantity, it can create a problem, or it can leach into their product, and that is a big problem in future as for the chemical toxicity. So it should be approved, it should be authorized. Now you open the chemical, and if you saw all the containers, they are same, means same size of container, and the color of the chemical is the same. So you don't know how to use it. So that's why you need a proper labeling on the wall, on that containers, that this is a chemical. And then you have to write down, if you are using acid or if you're using alcohol, you need to identify which is a toxic chemical, which is a we can skin irritant. So you need to segregate them properly. Then you should have a user protocol during the for the operation of the toxic compound or the chemicals. Like operational protocols means how much concentration you will use, how to dilute it. This is a cautious. It's not. It will be not the part of it, because I think we are running short of time. We have to cover a lot. So I'll just try to cover as early as possible. Then personal hygiene we covered. Then food prevention of adulteration. So it's up to yours, raw material specification, that you take a best quality of raw material, so there will be no adulterant into your food, and you can do it by different tests. Then prevention of cross contamination, that actually indirectly we have taken it, that we will have separate areas, and one person will not go the material equipment of one area will not go to the another. So you integrate or we send the integration of that area will be there. There will be the no passage between two areas. Even if there is a complete demarcation between that, at least between medium risk and or the low risk and high risk area. High risk area should have complete demarcation, that only the person who's working there will go there. So it's like, if you identify the high risk area, so like medium risk can go easily access. There is only separation, only the separation, like the strip films are there, but it need a exact like wall or the complete barrier of medium risk and high risk areas. Then condition and cleanliness of food contact surfaces. Condition is the cleanliness. You can use any different types of cleaning and a disinfectant protocol, and there is a how you're gonna check that. You can do it by swab test, you can do by the ATPase based test, that the cleaning is properly done. The safety of water and ice. We'll go in detail about safety of water and ice. I cannot go into detail, because as we talk about the QA and QC, in a QA, there are few things here: hygiene control, personal hygiene, then maintenance, safety of water, or near about all SSOPs. You can apply QA and QC. QA and QC is a basic, you can apply everywhere. So here, what we need, what are the procedures I will need, and what are the tests. So let's see, for the safety of water and ice, what can I need? First thing, what is the source of my water? My source of water is MIDC, or my source of water is the ground. Still, I want a consistent quality of water. So what are the criteria for the consistent quality of water? Let's say TDS is 100, then residual chlorine is less than 10, then it should be microbial, no E. coli, no Enterobacteriaceae, and then the APC or the TPC should be below 100. So this is my quality criteria. Now, how will I achieve it? I will do it by filtration, and I will do by the chlorination or the ozonation, any other thing. So I will do the filtration properly, then I will do the chlorination, then I will check. So this is my procedure for the QA. It becomes a QA. Now I will become the QC. So what will the test? I will check the hardness, I will check the TDS, or I will check the residual chlorine, I will check the microbial test, I will check the pH and other characteristics that I decided it should be in my water. So likewise, you have to prepare one procedure for everything, like safety of water and ice, then cleaning, then avoidance of cross contamination, personal hygiene, then prevention of adulteration, proper labeling, storage, then control of employee health. There should be a proper SSOP for that particular, for everything. I will just take some example what ideally that should be. So see, to write any SSOP, there should be an aim or objective, or it is called scope, goal. Then criteria, what's you gonna achieve. Then monitoring, what you will do exactly. Then if that fails, what you will do, that is corrective action. What will be the record, and verification, that by second party or third party, and who will do it, what is the responsibility. So this is an example for the safety of water and ice. Like, so what is your goal? That water should be safe. That I'm using, that water and ice, that should be a safe for the preparation and we can say cleaning or another situations, like whatever comes to what. So all the water that comes in the contact with the food and food contact surfaces or used in the manufacturing of ice is made a safe and sanitary source. So what is my criteria for this? No E. coli for 100 ml. APC should be 100. Residual chlorine should be 2 to 5. Then yeah, 100 milligram chlorine per liter. So this will be my criteria. Then monitoring. So when public supply is there, the official record from the water works suffice. That's okay. Then water from own supply. Say when there is water from own supply, what we will do? I will check the residual chlorine daily. I will have microbial documentation, or I will check the microbial contamination. I will have water scheduled. Then I will have a standard microbial procedures. Who will be the responsible? Chief QA. What will the corrective action? If any problem or any set criteria that I have decided, it does not fulfill. For example, I got the microbia. Like let's say I got the E. coli. So it indicates my chlorination or my killing bacterial stage or or the ozonation or the chlorination is not working properly. So I have to stop that water because I'm considering the water is a E. coli free. So I have to stop that water. I have to use my stored water previously that I used. I have to stop that water and I have to reprocess that water for the chlorination or the ozonation. So this is the corrective action. I should maintain the record for everything, even including corrective action. So all sampling, testing, action, others. It depends. For 2 years or for how many years, that's depend on retention policy. And once a year, I will send that particular water to the third party for cross check or the verification. So this is one of the example that is in industry. So you'll see the scope is there, responsibility is there, description procedure is there, frequency, and there is a reference to the record. So which record mention the in which record you are having the details of the safety of water and ice. Then as we are going for the ISO 22000, actually the clause 8.2.4, as per which are what are the PRPs which are mentioned as per the ISO. We'll just read it. Or it contains construction, layout of facilities and associated utilities. It contains layout of premises, including zoning, workspace, and employee facilities, supply of air, water, energy, and other utilities, pest control, waste sewage disposal, and supporting services, the suitability of equipment, and accessibility of cleaning and maintenance. Then it's a supplier approval, assurance processes, raw material, ingredient, chemicals, and packaging. That is an assurance processes. Reception of incoming material, storage, dispatch, transportation, and handling of product. Measures for the prevention of cross-contamination, cleaning and disinfection, personal hygiene, and product information to consumers. Indirectly, they have covered the same things. Here ends the PRP. Why PRP actually? Why the PRP is required. When you see the history of quality assurance and quality control, first actually start with the HACCP. But in HACCP, there was no concept of PRP initially, and so for people, they have carried out the risk analysis. Every time they take a hazard, they carry out the risk analysis, and they think it is a CCP. It is a very critical to the quality or very critical to the consumer. So in one industry, there are multiples of CCP, like 20, 25, 30, and to manage that CCP is a big task. So what happens afterwards? They took all the common hazards. What are the common and how to deal with that common hazards? So that is required. That so if we deal with all the common hazards, we can specifically deal with the food specific or industry specific hazard. So all that common hazards, when you call it, and the dealing procedures to that common hazards is comes as a PRP. I'll just give you one example. See, in a PRP, how will be the common hazard? Like, see, in a food industry, you have different areas. Raw material is there, raw material storage, distribution, or raw material store is there. Then you have pre-preparation area. You have a area-wise, separate rooms are there. Let's consider. You have a preparation operation area. You have a freezing area. You have packaging area. You have dispatch area. All the area. What are the common things? Can anyone tell me that? What are the common things in all the areas? Like from raw material. There are consider, like, if visualize, there is a room. Raw material room is there. Then pre-preparation room is there. Then operation room is there. Then freezing room is there. Packaging room is there. And then dispatch room is there. What will be the common things are there? Can anyone tell?
Quality assurance.
Yeah, but actually, see, quality assurance and quality control is it's a term that actually basic foundation that are there. I want to visualize that you are doing operation, or even in a home. Let's see, in a home, rather than industry, I'll give you an example of home. In a home, there are two. The hall is there, bedroom is there. What will be the common? They have different setup. Sorry, what will be the common in there?
Electricity.
Yes, correct. Electricity will be the same to the area. Though then air should be the same. The water you are using will be the same. The floor you are using will be the same. The side material, the wall material will be the same. The window structure, the lights means bulbs will be the same. These all are the common things. That they are the hazard. They can be the hazard. They are everywhere. So when you collect all the things and you make the procedures to that one, that becomes the PRP. So to how to deal with this common hazard will become the PRP, and it becomes the basic foundation for the HACCP. And that's what we see. If you go there and if you see, these are the common requirement. These are not specific requirement. These are the common requirement. So they are, every food industry, they have it. Every food industry, they must comply to that one. And now, for a specific hazard, we have a program that is called HACCP system, or Hazard Analysis and Critical Control Point. Any doubt in PRP?
No, sir.
No, sir.
Okay, great. Then HACCP. HACCP is called Hazard Analysis and Critical Control Point. It is a preventive approach. Preventive means you are doing it before the incident happens. So it is a preventive approach. Then it is a powerful safety management technique. It is proven and structured method. Why it is a proven? Do you know the history of HACCP? Anybody?
No.
It's a very interesting history to the HACCP. Actually, in 1950s or something, NASA has a problem. Actually, NASA, everybody knows about the NASA.
Yes, sir.
So NASA has a problem that for their space exploration, when their astronauts want to go, they need a food. And for food, they have two problems. One problem is that the food crumbs, when you just cut the biscuit or bread, the small particles are there. They 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 just like explode. So there is a problem of the crumbs, because in a space exploration there will be the zero gravity, and that crumbs can go there to their lung, go to the machines, and that can interfere. So there has one problem, that the food crumbs are there. Or another reason, how we can provide a food that will be the bacteria free, so the astronaut will not get sick over there. So because they do not have accessible uh, uh, health facilities in a space exploration program. So how will provide the food, so they, if they eat it, they will not get sick. So they have this problem, and then this problem has been solved by the Pillsbury. Right now it's called General Mills or the Pillsbury, by developing this HACCP. So HACCP is why I called it is a proven, or why it is called as a proven, because it is a space program. It has been used for the space, and then it is used for our industry. So I'll just elaborate the history. So first, they solve the problem of the crumb. They produce the bite-sized food. So just you have to take the food that is a bite size, so there is no chance of the crumbs. And then by implementing or by developing these HACCP programs, they solve another problem of the uh, microbial-free or products, or there will be no any health hazard to the food. Then in 1971, Pillsbury make it public. They communicate or they make it public, because previously it was their trade secret. Then they make it public in 1989. As we see, NACMCF, uh, National Advisory Committee for Microbial Criteria of Food, and ICMSF, International Committee for Microbial Specification for Food. They published paper of HACCP. In the same year, they both published different papers, but for related to the HACCP. Then it becomes well known, well aware. In 1993, Codex actually make their one standard related to the HACCP. Then it is near about make as a foundation or the must requirement for the food industry. And in 2000, in 2005, ISO, in 2000 ISO adopted it, and in 2005 they rolled out a one standard containing HACCP principles, that is the ISO 22000-2005. And there is a still near about second revision for the ISO. So this is the history of HACCP. So in a food industry, we are using a space program, which is especially deal with the uh, we can say zero defect, zero hazard into the food. So we'll go. Before that, we have seen definition of hazard and risk. We'll just little bit elaborate what is hazard, what is a risk. Then we'll see the 5 steps of the HACCP, 7 principle of the HACCP. Then there is a we'll see documentation, auditing, and ISO 20000. But first, this is very interesting. I will try my best to communicate you the nuisance or the details of the HACCP. Just bear with me. If just concentrate a little bit. If you understand the HACCP, you already hopefully understand the PRP. If you understand the HACCP, you can understand the documentation, and you can understand the auditing and ISO 20000 clearly. So please. So what is hazard? We already told it, or we already speak it, anything dangerous to our food and food consumer. So it may be physical, it may be chemical, it may be biological. This any agent that has a potential to cause an adverse health effect. Additional to the physical, chemical, biological, there is a new source of hazards are there, or the hazard is allergen and the radiation. So allergen and radiation, they have to deal separately, so we'll not gonna cover here. So what are the physical hazards? Anything that you can see, anything you can touch. This is a physical, tangible things you can touch. These are physical hazard. So it comes hair, stones, seeds, bone fragments, matchsticks, jewelry, nut bolts, then fibers, button, beads. So actually, in our certification program or for hazard, we said that they don't have legs, they are blinds. All hazards. We are saying whenever we start, means basically you understand that all hazards they are blind or they are they don't have legs. They need some agent. Through that agent, these types of hazards are came. So what are the agents? So as we listed, these are the few hazards are there. So what are these agents? This can be agent, can be people, environment, pest, equipment, or natural material. So what hazard people can give? So from button from their shirt, from jewelry, drawing pin, paper clip, matchsticks, pens. So depending on there will be policy that no jewelry policy, then uniform will be the button free, velcro will be there. So to avoid that one, so drawing pins, no drawing pins allowed, no staplers allowed, no pens allowed, or the pattern pens will the metal detector, metal pens are allowed. So like will that will there will be the policies. The natural material, the raw material itself can work as an hazard. There can be a nut nutshell can be work as hazard, seeds, fruit, stones, or even a bone from the meat industry. Environment, the processing environment, the glass can work as a means glass window there. If it is broke, it can work as a hazard. Woods, pallet, generally pallets are used for the storage. Chips from tiles, concrete, equipment. If a wearing and tearing of the equipment can bring the metal pieces and that can act as a hazard. Physical hazard, we are talking about the physical hazard. And the pest itself is a physical hazard. Their legs, their wings, their cuticle, can act as a physical hazard. So hazard, these physical hazard, they need an agent. So depending on there will be the policies, like glass policy will be there, pest control is there, equipment policy will be there, such a type of equipment is required, then such a type of raw material screening is required to avoid that hazard. We're gonna see that one. Then chemical hazard, all the things that you cannot, you can see, you can smell, these are the chemical hazards. So all the chemical things, but the effect of chemical you cannot see, just you can only sense. I'm telling you in a most, we can say, understandable. So chemical hazards generally comes from the chemicals that you are using in your industry. So what are the chemicals you are using? You are using cleaning agent, you are using disinfectants, you are using for the machine there will be the oils. If you are using nitro ammonia based refrigeration, then that gases. If you have printing ink, then you will be the printing ink. Okay, then chemical hazard from pest also there. I mean from few pest, they basically have their cuticle have such a chemicals that can be allergens to our consumers. Then fumes, dust that can cause a health effect, like fumes or the dust from the floor that you are using, that can have a hazardous effect to your employee, not to only to your product. So when you are talking about the chemical hazard, the hazard is not to your only food but to your employee also, that you have to take. Because the problem to the chemical hazard is that it is like a slow thing, like a slow poison, but don't use the slow poison, but the impact or the effect, it take a time. Like for example, if you have slightly higher concentration of the your hand soap, in that if there is a detergent solution has a higher concentration, over the years your skin will structure will change. So they need or it take some time, like year, month, to show the impact, and it will impact to your employee, it will impact to your food, but you will take some time to understand. So that's why you have to identify all the chemicals and whatever they're possible impact to our employee and to our food processing Then biological hazards. So biological hazard can pathogenic bacteria like Salmonella, E. coli, Listeria, parasite, protozoans like flatworms, tapeworms, flukes. Generally, this comes from the meat. Then viruses, hepatitis, or viral gastroenteritis, molds, fungus. So I don't think so. I need to elaborate biological hazard because I think mm, you guys are aware of it. But still, if you are a microbiological student, you will able to know that these hazards, microbial hazards or the biological hazards, not only cover only the microbiological hazard. It covers the like for example, even in the fish industry, there is a you know like there will be the parasites in fish, or there may be any other item. So I just want to confirm, or I want to reassure, because when the people from the microbiological, because I made that mistake in the beginning, that when we are talking about the biological hazard, there is a more concern on the microbial hazard, but biological hazard means all types of biological things. Maybe parasite is a living thing, protozoan, they are the living things. So bacteria also living things, obviously, viruses, molds, but these are the things more than the microorganism can act as a biological hazard. Basically, in the fish industry or meat industry can happen. Okay, now why to use HACCP? Previously, we told that there is an external pressure. Customer want it generally, or maybe there is a government want it. Another thing is it has a commercial implication, because if you know that you are following HACCP principles and your process is safe, yeah, and you can first thing, there will be a zero incident. So if there is a zero incident, zero cost, or if your product is safe, product will be accepted by more people. If there is no any customer complaint, then you over the time you will make some fame, you will make some name, then it is good for business. So having a HACCP is good for business. So it is a commercial implication. There is a traditional, as we saw the PRP programs, and there is some limitations for that program. So to overcome that limitation, we need a specific program that isn't HACCP, and there is maybe the requirement from our external pressure, like customer want it, government want it. Then we'll see some major food incident. That's why I want to elaborate the idea why we need an HACCP. See, in UK, there was an salmonella contamination, and it is due to the cause of this is a contamination during process. It affect 81. So that's okay. This number of people got 81, but for the claim, because when there is such an incident, there is a claim, there is an action. Means litigation is there. That consumer will go to the court and sue you, and that cost for that company for the food recall and litigations is a 3 million. Then there is for the French fries in USA, there was a wire bristles. It's a metal pieces. It is a incorrect action of the metal detector, and they have to collect, and how many people's they have to collect 4 tons of potato, and they have to destroy it. The cost is 4 million. So this is a commercial implication. If you don't have a proper HACCP or system, then another is a Coca-Cola. They contaminated the fungicide, and that is through the packaging process. 50 million people got sick or affected, and the we can say the cost is a 60 million. So if you see, the problem deals, or the not having of HACCP has a very huge commercial implication. So you have to bear that big cost. So it is in quality, it is called iceberg effect. So the impact is like, sorry, so iceberg effect. So you can only see the tip, not performing of the, or we can say the cost of quality. To perform that cost, you can have only see the only visible part. But if you don't have a quality, this, such a big impact can be to your business. So let's see what is the risk. We have seen it. Risk is an estimate of likelihood and severity of the hazard, or it is an then control measure. Yeah, you have a hazard, you identify the risk. Now you doing some action to control that risk. It is called control measure. So any action or activity that can be used to prevent or eliminate the food safety hazard or to reduce its acceptable level is called control measure. PRP we already saw it, so I am not going to elaborate it. Now 5 HACCP steps, or the 5 preliminary steps and 7 principles. It has an application of the 5 steps, five steps. See, 5 steps, consider that now let's take the example of one in budget. Now you have a plant, you have machinery, you have area segregation, everything. And now you're, yes please, anybody? Okay. So now you have everything and now you are going for the production. If you are in a new and you have to start from the scratch, then you have to go for this 5 stage. But your system is already there and you have to just check the any additional or a new hazard, then you can directly go to the 7 principles. So 5 steps is used mainly when you are starting from the beginning or the starting from the scratch. Then means in interview can ask you a tricky question. So let's see, I have industry, I'm starting from the scratch. How you will start the HACCP program? So HACCP program, when you are going to start from the scratch, you should start from the 5 steps. And the first step is assemble a HACCP team. Second step is describe the product. Describe the intended use. Identify the intended use. Then describe the construct the flow diagram and confirm the flow diagram. So for five steps are there. These are preliminary steps when you are starting from the beginning. So what is mean by assemble a HACCP team? I will elaborate here. What is mean by describe the product and intended use and flow diagram? Assemble a HACCP team. You need to prepare a team of multidisciplinary people. Why multidisciplinary? See, I'm from a food safety background. I'm a microbiologist, and my competence, my specialty is in microbiology. Means I can see I'm very good in microbiology, but I have a zero knowledge of the maintenance department. I don't know how they are doing it, how they are operating, how it's gonna affect. Because I need a bit. I just want to know. I need a 71 degrees Celsius, but to attain that, they have a PLC programming. They know the belt speed. They know the how the machines will work. They know the where does it will take that weight or not. Then the raw material people, storage people, everybody. So one people from like one from admin. Like this, you need to. Hello. So
Hello,
like
sir.
this.
Hello, sir.
I think my connection was unstable. So it's okay now.
Sir, okay, sir. Okay.
Okay, fine. Can we continue?
Yes, sir. Yes.
Next 10.
So such a way, I need a multidisciplinary team. So when we are going for a construction of flow diagram and determination of hazard, all these different types of people can give me input that this can be hazard. This is not a food safety hazard, but this can be mechanical hazard. This is a hazard from raw material. This can be hazard from the packaging. This can be hazard from the cleaning chemicals. So like this, I need a multidisciplinary team. So when you are going for the development of the HACCP team, there should be a multidisciplinary team and there should be one team leader who obviously has a responsibility to the manage that particular team. Then describe the product. It is called product specification. Describe the product. So when you are going to manufacture the product, describe everything. how you will produce, what is the raw material for that product, what will be the packaging, what will be the lot, what will be the coding structure, describe everything. Then identify the intended use. Who will be your consumer? Who gonna consume it? You know the four category of consumer, guys. You know the category of consumer.
No, sir.
See, hello, please.
Primary. Hello. Hello.
Actually, fine. Actually, there is some sound disturbances. That's why I'm able to hear. But I will tell you. See, the food that is for the child, the food that is for an infant, is the same to the food that we are eating.
No,
Does
sir.
it? No. Yes. The food that pregnant woman is eating, it will be the same for the normal people.
Also, no.
The food that is for the elderly people will be the same for that we are eating.
No,
So correct. So these are the four different categories that to whom you are producing. Either you producing for infant, either you are producing for pregnant woman, either you are producing for the general public, either you are producing for immunocompromised or elderly people. So these are the categories of the people. So you must know from whom you are preparing. So once you know that whom you are preparing, you can able to concentrate. So like when you are preparing for the infants, now you have to know that infants do not have the immune system. They have a weak digestive system. Then they don't have a teeth. They don't have a proper digestive system. So then you will prepare your formula accordingly, that how it will be digestible, how or mainly how it will be liquid formula so they can eat it. Or if you want to prepare the water soluble formula, so you have to prepare the water soluble formula. So you have to prepare the steps. Same goes for the elderly people or the immunocompromised people. So what they want, this is their for their convenience. And for general public, they can eat it. Except in general public, there are people who have some allergies, so you have to mention the allergies on your packaging material. So like this, if you know what is the intended use, who's gonna use this product, then you know how I will process it, how how I will better serve that category of people. Okay. Then once you have it, you already through the PRP, we have decided that we need a receiving. We'll do receiving, preparation, then store freezing, and in our onion bhaji example, and storage. You have prepared this is what it is called flow diagram, like receiving, storage, receiving dash storage, then preparation, then frying, then freezing, then packaging and labeling, then storage, then dispatch. So this becomes your flow diagram. This is a basic flow diagram. Now go to the receiving and confirm a flow diagram. When you go there, like receiving and storage, you'll able to see before receiving there will be the vehicle check, vehicle inspection, then there will be the receiving of material, then transfer of material, then there will be the sampling, then after that sampling it will go to the quarantine area or the hold area, then from the hold we have to wait for the microbiological result, then after microbiological result it will go to the release area or in a production. From the production we have we have to store onion differently, then we have to store flour differently, we have to store oil differently. During storage also, that new material that we have to store backside. So when the people from the processing will come, they use the old material, that is FIFO and FIFO maintenance. So such a way you will see that in a one step there is a different flows are there. So detailing of that. So you go there and confirm the what is the flow diagram. So first flow diagram you prepare the basic and you then prepare the detail and you go to the that particular area. You don't have to sit. So this HACCP is a practical. It's not a mental process. It's a practical. So you have to go to that processing area. Yeah, if you are going receiving, I will go to the receiving, I will check what are the steps, I will write down the steps, and then at each stage, what is hazard, physical, chemical, biological, I will check. That we'll see in next, but this is it. So you make a foundation for our HACCP principles or the basic or ideal HACCP procedure. You got the 5 principles or any doubt in this?
No, sir.
No, sir.
Okay, great. So if anything missing, I will just check. No, hopefully no. Principle, yeah. Now we have to see 7 principle of HACCP. Now you have a team ready. You know the who's your consumer. You know the product specification, how you will pack it, what is the packaging, how you will produce it. So you know the product specification. You know the intended user. You prepare the flow diagram. You have each and every details of your process. Now you are ready for conduct and hazard analysis. Once you have a flow diagram, detailed flow diagram, take a one step. Now this conduct a hazard analysis is applicable. I'll just go to the next slide so you'll able to understand. Let's see the receiving. In receiving, as we see, there are vehicle inspection, then transfer of material, then testing, then holding, then release, then storage in a specific area. So take any one step here, like vehicle inspection or any one step, and in that stage you need to carry out this hazard analysis. So that I want to, why I hurry before explaining all the principles, because you are not applying for receiving. There are short steps, and then combine, you will prepare in a documentation that this is for a receiving, these are the hazards. But you have to break down the steps, and then you have to check what is physical, chemical, biological hazards are there. Okay, this is a physical hazard. Then we'll whether it is a candidate for the CCP or that we'll see. So what are the, I know I directly started it, but that's the concern, because you should understand the link between the 5 steps and 7 principles. So generally this is called 7 principles, which is first is a conduct a hazard analysis. We'll see it all, we will all see in detail. Then determine a critical control point. We'll see how we'll determine the critical control point. Then we'll see the critical limit, how we'll establish a critical limit. Then we'll see how we'll establish monitoring system, corrective actions, verification procedure, and the documentation of all first 5 steps and these 6 principles. I will try to show you one document will cover all these steps, so you will get the idea of what's going on in industry. So first, conduct and hazard analysis. We have a detailed flow diagram. You take a one step from that flow diagram and you check what is physical, chemical, and biological hazard. Once you know that yes, this can be physical hazard, this can be chemical, this one, you take one hazard. Now you have to identify the risk. So what is the risk that we see briefly? What is the likelihood and severity of that hazard? So you quantify that one. What is the likelihood and what is the severity? And then we will see the control measure. What are the control measures are in place? Yes, whether the PRP is there, whether PRP is dealing with, means prerequisite programs are there. Can PRP, like for me, like there is a hazard of water. But water, we have a very good prerequisite program for safety of water next, so it will be controlled by that. But still, we have to carry out quantification of the hazard, and that is carried out by likelihood and severity matrix. You understand this point? Because there is, if you don't understand this link now, otherwise you will miss the connect of further steps. Do you understand the connect here, that we have to check one step and then you have to check in that physical or chemical or biological hazard is there, this hazard is there, now we have to quantify that hazard. Did you understand here? Or if there is any doubt, please ask me here. I'm considering this is as a no doubts. Okay? Or you don't understand? Hello, guys.
No doubt, sir.
Great.
Understood, sir.
So once you are doing, once you understand that at this step, this is the hazard. So take any hazard. Like we have one biological hazard. So what is the risk? There is a risk of the food infection. Now, but we'll go to quantify that hazard through the likelihood and severity. And this is a 3x3 likelihood severity matrix. And from that, we'll quantify that hazard as a low risk, high risk, or medium risk. So basically, it is a very basic scale. Generally, in industry, 5x5 scale is used, but for your basic understanding, you can, if you go and search what is a 5x5 likelihood severity matrix scale, then you will get it. But this isn't basic, so you will understand it. So we'll elaborate it. So what is a likelihood? Likelihood is a probability or the impact or the occurrence. So what are the chances of the occurrence? So 1 means when you will score as a 1, this is a score, 1, 2, and 3 is a score. Then in a severity also 1, 2 is a score. So when you will give a score as a 1 in a likelihood or in a probability, when it is an extremely unlikely. Means for example, you check that this is the hazard. Yeah, there can be the hazard. How many times it will come? This is a probability. How many times it will come? Oh, it will come very rarely. But if it came, what will be the impact to my food? That is a severity. Does people will get sick? Does this food will destroy? Or does my people who is working, they will get infected? So what is the impact? So impact can be fundamental to operation or the critical to the operation, significant or non-critical. So the probability is also rarely, likely, and extremely likely. Means when there is a 100% chance, it is extremely likely. When there is a 50% chance, there is a likely. And extremely rarely means less than 10% or less than 1% also we can say. Impact, non-critical means it will not impact anything even if it has that. Significant, it will impact, but we can able to manage it. And the last is a fundamental to continual operation or the severe, highly severe. It means if it impacted, we cannot able to correct it. So 1, 2, 3. So 3 score is given to, in a severity section, 3 is given to the fundamentals to the continuing operation or highly severe. Same goes to the likelihood. Rare to likely means extremely likely. 3 is given to the extremely likely. And this is just this one into this one. We will get the 1. This 2 into 1. So this 2 into 1. So this 1 to 2 scale. Then same 2 into 1. Then 2 into 2, 4. 3 into 1. You got the idea how the matrix work? 3 into 1. So this is a 3. 3 into 1. Then 2 into 3. 3 into 3, 9. Any doubt here? Then 3 into 2. So this matrix is decided. So then when there is a score of 1 to 2, that is a low risk. When 3 to 4, that is a medium risk. And then there is a, if the score is above 6 up to 9, it is an high risk. So you quantify each and every hazard on this scale. The low risk means it will be covered. It will be covered through the PRP. Now you have to concentrate on the medium risk and high risk. This medium risk and high risk can be the potential candidate for the PRP, for the potential candidate for the CCP on OPRP. So once you have this medium risk and high risk, if there is a low risk, that is not an hazard. Don't follow that one. If there is a medium risk, then you have to go to the next step, that is a determination of the CCP, and which has been carried out by using CCP decision tree, which has a 4 basic questions. And this question I will read it. So these 4 basic questions, in that if first and second question is yes, that will be your CCP. If first question is yes, second question is no. If third, like yes no yes no. If first yes, second no, third yes, fourth no, then it will be the CCP. Otherwise, it will be not an CCP. It will be OPRP, because we are taking medium risk and high risk candidate. So if it is not CCP, it will be OPRP. At that stage, we have to do the some critical monitoring to reduce that hazard, but it is not a CCP. So why? Which decide the CCP? So you take the high risk hazards and medium risk hazard for every step. So every step, once you got it, you got the low risk, you eliminate that. So it's not the part. So in that, all the receiving stage, you got it the microbial stage. All the receiving small steps, you said the microbial testing is an high risk criteria, or it got the near about 9 score. So you go and you will ask whether it is a CCP decision tree or not. So in a CCP decision tree, you will go, I'll check whether it is a CCP or not. So do preventive measures exist at this step or the subsequent steps for the identified hazard? Yes, because if you are going for the frying, there will be the preventive measures that will take care of the bacteria. So yes, does this step eliminate or reduce the likely occurrence of the hazard? This is just sampling stage. So it will be no, because this will not this sampling stage or the microbial analysis in raw material analysis, that will not eliminate or reduce or likely occurrence of the hazard. So that is not that will be only the sampling stage. So it's a no. Food contamination with identified hazard occurs in excess of acceptable level, or could this increase to unacceptable level? It's a no, because whatever the in a raw material, it will be there. So then it is a stop. It's a not in critical stage. Wait. So it will be not a critical control point. So the sampling will be not a critical control point. That will be an operational procedure. Let's take the frying procedure example, because frying obviously you will score high in a risk analysis likelihood severity matrix, and that will be, see, do preventive measure exist at this stage or the subsequent steps for the identified hazard? Yes. Does this step eliminate or reduce the likely occurrence of the hazard? The microbial hazard is occurring here. So this is the elimination stage. Yes. Then it will be the critical control point. You understand this? Or any doubt?
Yes.
Okay. So once you know that this is a CCP, then you there can be a different types of CCP, like receiving can be CCP, thawing can be CCP, mixing or handling of the food can be CCP, cooking, reheating, hot holding, product formulation can be CCP, chilling, chill storage, and chill display can be your CCP. So these are the CCPs. Okay. Now you have to decide the critical limit. That critical limits that we have spoken about the frying, that this is a killing stage and cooking stage, that what will be the core temperature, that 71.7 degrees Celsius of 15 seconds. But what is the target organism here is a salmonella. So critical limit, that 71.7 means which organism you are targeting. If your organism is for example listeria, then you will have 72 degrees Celsius for 2 minutes. So that will become your critical limit. For a storage, if you identify as a frozen storage as your CCP, below minus 18 degrees Celsius will become your critical limit. So that you need to identify as a critical limit. And there is one issue. You cannot work on a critical limit. For example, if you work on a 71.7 degrees Celsius, and if there is an plus minus, you cannot accept plus minus here. If there is a minus, let's see 71 degrees Celsius is there, 71 degrees Celsius, it means there is a chance that salmonella can survive. So you need a working limit. Working limit is more stringent than a critical limit. Let's see the same example. 71.7 degrees Celsius for 15 seconds is your target. Then your working limit will be the 72 degrees Celsius for 15 seconds. So, or I will say 71 if the cooking does not, that temperature does not affect the texture of the material, then 72.7 degrees Celsius, so plus minus 1 degree Celsius. So higher it's okay, lower it will come to the 71.7 degrees Celsius and there will be no harm to your food. Okay, so you understand about the working limit. This is working limit. And choosing critical limits, it always has a combination like time, temperature. Means you can say if you want to pasteurize, it's not only 71.5 degrees Celsius, it's a 71.5 degrees Celsius for 15 seconds. Then if you want to use it, like reheating is there or the hot holding is there, like 65 degrees Celsius for 2 hours. If you are cooking it, or I can say freezing is there, that at this temperature for this time. This is only about the time and temperature, but it is always supplied or supplemented with, like for example, chilled item below 4 degrees Celsius, you can keep it for 1 month, 2 months, depending on the product. Like minus 18 degrees Celsius with the shelf life of 1, depending on the product, up to 1 year, 2 year. So like this, your limit will be there. Then metal detector, aluminum piece 0.1 mm, SS piece 0.2 mm, then mixed metal piece or the non-ferrous or ferrous, it will become 0.3 mm. So this is a critical limits that is for each stage. So metal detection for allergen, for somebody can identify. So it depends on their hazard analysis, how you understand your hazard analysis, how you quantify the risk, and then for you, if it is a high risk, and then you consider that is a my CCP, and that particular CCP, there will be the critical limit. So if you determine your CCP as in metal detection, then you will have a critical limit. Then after critical limit, you will have a working limit, which is more stringent than a critical limit. Why? Because if their working limit fail, still you are in under the critical limit. So still you are good to go for the procedure. Once you have a critical limit, you have a the set of parameters like time and temperature, or the we can say the processing parameter, this type of concentration of the chemicals for this minute. So you got the parameter. That parameter has been used for the monitoring activities. So you go for the monitoring activities. So that particular parameter has been used for the monitoring procedures. So, and all other monitoring procedure. And then monitoring procedure, depending on the severity, it is you need a procedure for a monitoring procedure. You need a frequency. Who will do it? How will do it? If it is on CCP, so you need you may need a separate CCP operator. You need a separate people who will do it. So people should able to do it properly. So you need a procedure, frequency, and responsibility for the monitoring procedures. Then we'll go for corrective actions, or we can say you have to consider if this CCP fail, means what the failure of CCP means. I am unable to, or that particular process or particular steps is unable to achieve the desired output or that desired process requirement, that what was the temperature like this, or what was the testing requirement like this, that is we are unable to achieve that. So that is means it's a failure of that stage, and that can be critical to your food or the food consumer. So you have to consider what if it fails. So then, like for example, What if it fails? Whatever the action you are taking, that is called corrective action. So there is two types of corrective action that we previously saw in a definition, that is corrective action, corrective action, and preventive action. So corrective action is immediately, the corrective action has been taken immediately to reprocess that product to make it safe, and the preventive action that that problem should not happen to this product or and all other products. So it should be carried out by responsible person. They are documented. They should be documented, properly documented, should be approved by the senior management, and it should be as per the food safety requirement. Let's take one example of the corrective action. Let's see, your fryer in onion bhaji, the frying unable to give you 71.7 degrees Celsius. If that onion bhaji can bear the second cycle of frying, you can go for the second fry, and you can attain the 71.7 degrees Celsius, and you can reprocess this. This is a corrective action. But what if it can unable to bear it, and still there is a problem that the temperature has not, you have a doubt that there is a temperature is not at all. So you will do, you take the product, raw product, you will store it differently. You take the microbiological test. If you think the microbiological able to detect the bacteria, then you will go, then you, depending on the microbiological thing or microbiological testing. For example, if the microbial, like for the staph or the for E. coli, it came positive, you have to reject it and dispose it off, because you cannot reprocess it, so you have to dispose. This is your corrective action. If the microbial test is satisfactory, you can go for the next steps. But here you have to decide the detailed microbial testing, and it should be approved from the senior management. The same goes for the cleaning, for the metal detection. Metal detection is carried out, generally metal detection is carried out for continuously for 1 hour, but still you think there was some incident that happened to our company and that is affected to that lot. Then what we'll do, so we'll take all the material, we'll pass again to the metal detector, we'll check it, is there anything, or if, for example, for last 2 hours there was no any reading, so likewise we'll check it. And if there is any requirement of, we say, reprocessing, reconsideration, throwing, or we can say communication to the concerned agencies, all this is an what if scenario. You have to consider that what will happen, what if this happen, what we'll do. So this is an corrective actions. Then you need to validate it, validation. So corrective action, verification, and documentation. We saw validation already here. So validation can be done by two things: by giving a load test. Let's see the see guys, maybe it's quite lengthy, but thanks for bearing with me. But I want to ask you one question. Do you know the autoclave validation? Hello. Does anyone communicate me about autoclave validation?
So Bacillus thermophilus spores are used.
Yes, yes. So what actually we are doing in a validation? So in a Bacillus thermophilus, we are giving a load test. This is called load test. You are giving a load of bacteria, and we will check, because this bacteria is killing at let's say 121 degrees Celsius for 15 seconds. So if that bacteria is not survive, it means we have done properly. So the same bacterial load test, we can do the pasteurization. The only problem that I have communicated is that we cannot do it in a industry, because there is a risk of the direct contamination. So we have to do it in same environment. So we'll check that load test, and then we have to validate everything. See, our work means, for example, the cleaning, or the how many CCP you have identified. So CCP you have identified receiving, if you identify the pasteurization or the frying or the killing step, freezing, and metal detection or dead coding. So you have to validate that whether that particular step is acquiring the intended use or not by different states. So you have to validate that routinely, and you have to validate the HACCP step as an overall HACCP step. How you will validate that in a HACCP, what is the scope or what is the aim of HACCP? There should not be any hazard should present in our food product at the end, or in a finished product. There should not be any hazard present, or it should be at least to the acceptable level by the government or any legal body. So either it should be eliminated or it should be up to the acceptable level. So you do the cross check of that. You do the testing. You do the third party testing. You do the internal testing. You do the efficiency testing. So like this, you do the testing and to understand. This is called the validation of HACCP. Once you have this, you need so many things. Once you are monitoring, you have to verify it. We already speak about the difference between monitoring and verification. So monitoring is a set parameter like time and temperature. So you check it. But verify will be that you will go, you take the material and you check the temperature, that will come as a verify. But verification of HACCP have so many things. Like CCP monitoring is doing it properly or not. So there will be the specific person who will verify that all the things that we have decided in a CCP monitoring, so whether critical limit is achieved or not, whether the CCP operators they have proper training or not. So like this, we have to do it during the implementation of HACCP program. Fine, and finally you have to review. One second. Yeah. You have to review and maintain the HACCP system. So verification activities can be done by the audit, all the types of data, training, and ensuring you have proper HACCP plan. So I'll just show you HACCP document. So we can have a look of HACCP document. So this is one document that we have for the imitation crab claw or nugget. So this is our, here only there is a HACCP team step was not there, but this is the your product description. So what is product description? So it will be like this. What will be the source of raw material? What is the raw material used? What is your finished product? What is an ingredients, additives used? What is its intended use? Who is the intended consumer? What can be the potential misuse? Shelf life. Okay. Then this is a process flow. So how it will be the process. Then where the marking of the CCP, CCP1, CCP2 like this. So this will be the product flow sheet.
Hello, sir.
Yes, please.
Slide is not moving, sir. Yeah. Is it
That
showing
is
just documentation?
Actually, for my screen, I can stop and share once again.
Yeah, okay, sir. Shall we take, sir, break for 10 minutes?
No problem. No
Is it
problem.
okay?
Actually, it will end the HACCP. So we can take a break. It will end in HACCP. So we can take a break. Just have to show them a document actually.
Sir, can you please ask to the participants, please?
You can you able to see the document or not?
No, sir.
No, sir.
No, sir.
No, sir.
No, sir.
Fine. I will stop and I will show you. In 1 sec. Now you can see.
Yes.
Yes.
Yes, sir. Yes.
Fine. So this is what we have seen in a 5-step and 7 principle. The first step was the product description. So this can be the document for the product description. So depending on industry, it can change. So here we have raw material, then what will be our finished product, what are the additives, what is the processing gate, who's our intended consumer, what will the intended use, shelf life. Then we'll have a process flow sheet. So this way you can prepare the process flow sheet, marking the CCPs. Okay, I will not go into the detail, but this way you have to prepare the each and every stage. Then you have a process description, that each and every step how it is prepared. So these are 5 steps. Huh? So these first 5 steps have been covered here. Up to that you have how your means product description, process description, and flow sheet. So first 5 steps you have been covered. Now we are entering into the 7th principle. So this here one step, what is a biological hazard, what is a chemical hazard, what is a physical hazard. So then we'll carry out likelihood and severity. So what is actually the source of the that actually the justification or the source of that hazard, and what will be the likelihood and severity. Is there any procedure to eliminate that hazard, that is with the PRP or not PRP. Then we'll apply the means once you quantify the hazard by likelihood severity and apply the critical control point decision tree, and then you will able to know whether it is a CCP or not. So here only this is an only hazard analysis step, first step. So this how to done for entire operation, entire steps until dispatch. Once you've done this one and you identify the CCP, you need an HACCP plan for the CCP. Let's say this is in pasteurization. So you decide the critical control point, you know the hazard. Now what is the critical limit? So you have decided the critical limit. So this it is a cooking stage. So for that it is an 85 for 25 minutes. Then monitoring. So second stage, second step, second principle, third principle. Then monitoring is fourth principle. So what will be done, how will be done, what will be the frequency, who will done. So like core temperature of the product will be checked and the will be checked, and the pasteurization period will be checked. How will it check? It will be checked by the thermometer and belt speed. It will check by hourly. Who will done? Processing supervisor. What if it fails? Repasteurize or disrupt evaluation. And what will the corrector? Readjust the belt speed and repasteurization. So it will be your corrective action. What are the records? Okay, so the records are what water temperature, corrective action record, validation record, calibration records. So this is a record stage. So this second principle, third principle, fourth principle, fifth principle. Verification is your sixth principle, and record is the seventh principle. So how you will do the verification of pasteurization? So daily record you have water, then you have validation record, you will have calibration record, annual calibration record, annual validation record, you will have microbiological report, daily finished product, microbiological parameter, annual testing. So likewise you will have it. Same goes to the metal detection. You understand this?
Yes, sir.
Okay, fine. If possible, we can take break now, and we can continue for remaining part if the time persists. I think I already uh, 8, 9, 10 already finished my time, and we have few auditing documentation ISO are remaining. If the time persists, we can go for another. So we can do for, we can take a break. So Patil sir, if possible,
sir,
we
yeah.
can take a break, and if time persists, we can continue our session.
Okay, okay. So participant, you just go for the lunch break. So we are going to be meet after 30 minutes. Sir, is it okay, sir? After 30
problem.
minutes.
We are continuing the session because maybe another host or this lecturer is waiting for me. So, do we have a time?
No problem, sir. You start remaining things after the 30 minutes, and
Fine.
directly we are go with the interactive session. You may with us for the interaction with the students and along with the next session guest also. So we are
Fine.
actually cancel the uh, session of the next session guest, but
Okay.
they are with us for interaction only. Means question answer type.
Okay. Okay. Okay.
Okay,
Thank
so
you. And
yeah,
sorry for the inconvenience.
yeah, no problem, sir.
Okay. Okay. So
So,
fine.
so participant, you just go for the lunch break for 30 minutes, and after 30 minutes with the same link, you just join with the us. Thank you.